Good morning, everyone. Thank you for being here. Let's welcome Christos Markou. He will talk about observability and open standards with Python. Enjoy.
Thank you. Can you hear me? Yes, that's fine. So, good morning, everyone, from my side. Thank you for joining the session. I hope you are enjoying the conference so far, and let's talk about Python and OpenTelemetry. So, I'm Christos. I'm a software engineer at Elastic, and I am mostly focusing on observability space over the past years, and over the past 2 years and a half now, I have been an OpenTelemetry contributor, where I am approver and code owner in various sub-projects of this ecosystem. And I am also a CNCF ambassador, where CNCF is the Cloud Native Computing Foundation. Let me ask you, who of you are familiar with CNCF? Okay. Who of you are familiar with OpenTelemetry? Okay, and I guess you are familiar with Python, so I'm not going to ask this. But yeah, so CNCF is the Cloud Native Computing Foundation. It is an open source foundation that maintains projects like Kubernetes that you might know already. OpenTelemetry is another CNCF project. Then Argo CD, Prometheus, these sort of cloud native projects belong to CNCF. And OpenTelemetry specifically is about observability and is the second most active project in this foundation, right after Kubernetes, that you might know already. I think it's quite popular, so you might have seen this, but you don't remember this now. So if you are dealing with observability, this is something that you definitely need to check at some time, because it has very big momentum right now and is getting the standardized way out there to implement observability. Based on open source tools. So yeah, I will start with providing a definition of OpenTelemetry. And first of all, I like to think of OpenTelemetry as an open source observability framework. And specifically, it is a set of specifications and implementations for observability. Usually, we refer to it as OTEL. It is the acronym, so if I mention OTEL, it is OpenTelemetry. I'm not drunk. So yeah, with OpenTelemetry, you can do multiple things. For example, you can use the language-specific instrumentation libraries, for example, for Python, so as to instrument your applications and start collecting telemetry signals from them about how they are doing, their performance. Then you can use the OpenTelemetry protocol, also called OTLP, send them to another OpenTelemetry project, for example, the OpenTelemetry collector, which can run as a gateway, and it can receive, process, and export data to various observability backends like Prometheus, Jaeger, Elasticsearch, and so on. Now the protocol provides support for observability signals like traces, metrics, logs, and profiles. We also have another project called Semantic Conventions, which tries to solve the most difficult problem out there in computer science, which is naming. So Semantic Conventions provide guidance on how to name variables and your telemetry in general. So whenever you want to refer to the name of your service, for example, you don't call it service_name. We have a standardized way to call it, and this is service.name. So you have consistency across your telemetry and your observability data. And another use case is to have the collector running on the edge, which means that you can collect data from infrastructure, systems, databases, and any other use case that you might have for your observability needs. Now the signal, the protocol is a protocol buffer schema definition, essentially. And this means that we have specific structs that we can use. And for example, if we want to describe a log, we have the log record, and this comes with specific fields like the severity text, the body, and so on, others that I skip here, that you can use to describe your logs. And additionally, you can have extra attributes, which follow the semantic conventions, providing more context about your logs. And on the resource level, you can have resource attributes, as we call them, which provide information about the resources that emit this telemetry or are related to this telemetry. For example, the name of the host that you are collecting this telemetry or the name of the service that generates this log. So it is a protocol buffer schema definition implemented over gRPC and HTTP. Nothing really sophisticated. For Python specifically, there is a language-specific implementation, a library that you can use to instrument your applications and start collecting telemetry from them. And yeah, the project is organized with an API, which provides the interface to generate telemetry data, and then an SDK, which actually implements this interface. Now for the telemetry signals, OpenTelemetry for Python, the library is in a stable release for traces and metrics, but still an experimental for logs. But this doesn't mean that you cannot use logs already if you want. And you can find the link to understand more about the life cycle of stabilities. And now that we have a nice overview of what OpenTelemetry is, let's try to understand a little bit the signals, the observability signals, for those that are not familiar. I guess logs and metrics is more straightforward to understand. Maybe tracing is not that much, so let me ask you, who of you know about tracing? Who of you have collected traces? Okay, fine. So I like to think of traces as transactions, which means that while the application is executed, you start tracking the application execution so as to know the performance of this application. And a trace to me is like a transaction, which means that the whole execution, for a whole complete execution of your application, for a specific action like to get all the customers of your application, we have a single transaction, a single trace. And then for smaller execution blocks, we have the spans, and all these come with their IDs. So in this example here, we are the customer, we want to get the user, we want to get all the customers from the API service. So we start with a transaction, this comes with a trace ID, and then we start with a smaller block, the span, with its own different ID, and then the API service makes two different requests to another microservice, for example, a customer service or another service in general, and then we have two different spans. So we have three different spans with three different IDs, and all these share the same trace ID because they belong to the same trace, the same transaction. So we can build a dependency graph with all this information. We can track the execution of smaller execution blocks or for the whole transaction, and we can start like getting nice insights of how our applications are doing. We can even draw a dependency graph and know how the microservices, for example, interact with each other. And this is also called, in distributed applications, distributed tracing. And I guess that's all about tracing in general. And in order to implement this in Python, we can use the OpenTelemetry library. In this very basic example here, we start a trace provider. We also attach some resource attributes to it so as to know the service that emits this telemetry. And then we build the telemetry pipeline, as we call it. So first we have the provider that generates the telemetry. Then we can have processors, for example, a batch processor, which can probably batch the spans or the traces if needed. And then finally in the pipeline, we have the exporters usually, which are used to export the data to another system or to the console or whenever you want to send them. In this example, I use the console exporter, which just sends the data to the console. And finally, the important part, I create a trace and a single span with the name foo. And inside this context, inside this span, I execute this very interesting thing, this hello world print message. And if I execute this, I will see in the console the hello world, and the exporter will send also the span in the console. And this is the first span that we can have. This is the first telemetry signal. This comes with a trace ID and the span ID, additional resource attributes, the service name, for example, I mentioned. We can find the start time, the end time. We can calculate the duration of this execution. So we can start building nice insights for the execution of this important application, the hello world. Now for logs is more or less similar. In this example, I have traces and logs in the same example. So for logs, I need to also start a log provider. Again, I need an exporter. In this example, I have an OTLP exporter, which means that I can send the data to an OTLP remote endpoint that can receive OpenTelemetry data. use the provider, I register this with a handler, then I will do some logs. And the most important piece here is that I will generate a log, an error log, the very last one here on the bottom, and I will generate this as part of the specific context of the specific span, the foo span, and I want to see how these two different signals, the span and the log, can be correlated to each other. So on the left side, I have the span, similarly to what I had before, with a span ID and a trace ID. And on the right side, I have the logs that are sent to an OpenTelemetry collector that can receive OpenTelemetry data. So it's another component, but this is not the important part here. And the log looks like this. So I have the body of the log, which indicates that we have a major problem. And here I can see that this telemetry has come with, is linked to the trace and the span that is actually related to this log, right? So I can start, for example, investigating this log and then link to the other signal, the trace and the span. And I can see, for example, what are the dependencies to this span and start investigating the problem more. And vice versa, I can start with a span if I identify that the execution time is very big, for example, and something seems problematic. I can jump to all the correlated logs and start investigating the messages there. And we call this in observability signal correlation, and something that is usually very useful. And last but not least, metrics. Again, we can generate metrics from our applications. We can use the OpenTelemetry library again to start the provider, and then define different types of metrics like counters, histograms, up-down counters. We can interact with these metrics. For example, in the demo later, we will have a counter which measures the recommendations that our service does, and we can calculate, for example, the rate of the recommendation service. So if this rate goes down, probably something is wrong, unless the traffic is actually down because users do not use the application. And this is more or less about instrumenting our applications, but you can notice that I need to change the source code, so I need to manually instrument the applications, as we call it. It's called actually manual instrumentation. Yeah, and if I send these metrics to the collector and then to the console, the data look like this. Usually you need to send the metrics to a backend like Prometheus and start like visualizing the data or creating alerts and so on. And things can become more interesting if you use the auto-instrumentation support that OpenTelemetry provides, which means that you don't need to change the source code a lot. And in this example, if you have a Flask API server, you can use the OpenTelemetry instrument wrapper, which is actually an agent that uses monkey patching to wrap the methods and the functions at runtime of known libraries and start generating telemetry from them without you having to change the implementation or whatever. And there is support for known libraries. So for example, if you're using Flask or Django or other known libraries out there, this wrapper here can provide telemetry instrumentation out of the box without need for manual instrumentation. Usually you need a hybrid approach because you also need to instrument the parts that are not instrumented automatically. So to make this example more complete, here I have a client code. I manually have to instrument this. I have a client span. Then I create another span, which is the child of this span, just for the sake of the example. And then I will execute a request to the server. And yeah, we will see what will be the output. Everything goes to the console in this example. And you can also find the examples online. Then, yeah, right. First I have the client span. Then I have the child of this span, the client server span. You can see that I already have this relationship here because they share the IDs. The parent ID of this span is the span ID of the first one. And then I have the context propagation to the other side, to the server application. And this comes from the auto-instrumentation part. And again, this is a child span of the previous one, and all these share the same trace ID. So I can see how already I can identify a relationship and draw a service graph between these two different parts of the application. Right, so yeah, the important part here is that on the left side we have the manual instrumentation. outcome, and on the right side you have the automatic instrumentation generating the telemetry automatically for us. Now, yeah, based on the first question, who is familiar with Kubernetes, I guess you are not running on Kubernetes your services. So, yeah, anyone runs on Kubernetes? Very few people. Okay, that's fine. So, Kubernetes is an orchestrator to run that you can use to run containers to deploy your applications. So, auto-instrumentation can become even more seamless on this example. If you're running on Kubernetes, you can have the OpenTelemetry operator, which is actually another application. It is a controller and can automatically identify applications that can be instrumented by watching the API server of the Kubernetes cluster, let's say. And it can mutate, can patch the specification of the application at runtime, and without you having to change the entry points of your containers, for example, or downloading all including the dependencies in your Docker images, for example. The operator will do this for you during the deployment time. How this will happen? You need to install the instrumentation resource on the cluster. It is something that the operator can understand, and specifically enable the Python instrumentation. And then all the applications that we want to have them instrumented, we need to annotate them with a specific label, the instrumentation inject Python, set to true, and then using our images without changing the entry point or having dependencies included, we just deploy this on Kubernetes, and the operator will do this for us automatically. So this provides a more seamless experience for users, and yeah. And another example from like real world, let's say deployments, is when you want to ensure the resilience of the log collection for your observability solutions. So, for example, if you have logs that contain crucial information that should always get collected, it might be risky to send them directly from the SDKs, from the instrumentation libraries, directly to an observability backend using the network, the OTLP protocol over the network. Because if the network goes down and the application crashes, then you won't have the chance to collect these logs. So in this example, in this case, you can consider writing the logs directly to files and then have another component to asynchronously collect these logs. And there is a nice blog post in the OpenTelemetry blog about this deployment strategy. And yeah, the thing here is that the instrumentation libraries are configured to write the logs to files, usually, as we know logging traditionally. You can use a specific format called OTLP JSON encoding, and then you can have the collector scraping these logs, extracting all the information, unmarshalling the OpenTelemetry data, doing, for example, further processing like adding additional metadata from the host or your containers, whatever, and then send the data to an observability platform. Yeah, it's a very interesting use case. You can check the blog post. It's something that I have seen users being interested into this. And in order to achieve this, you need a specific exporter to translate the OpenTelemetry data from the library to the OTLP JSON format, and either write this to the console or write this to a specific file. Unfortunately for Python, there is no such exporter yet, so I had to implement this and experiment with this on my own. This is the source code. You can find this GitHub source, this gist here. And I also filed an upstream issue for the library, so maintainers have found this interesting, so probably this is something happening soon. And yeah, the OTLP JSON format looks like this, so it's the OpenTelemetry data in a JSON format, and we have one log record per line, and then we can use the collector to parse this back, do additional processing, and so on. There are some specific components that you can use here if you're interested to check them. And now we will see how all these can work together with a demo. I will be using this OpenTelemetry demo, which is the official demo of OpenTelemetry. It is actually a web store that sells telescopes and related stuff, because OpenTelemetry's logo is a telescope, so that's the reason. And yeah, it is an application that consists of multiple microservices. All these are written in different languages. Only this small one, recommendation service, is written in Python, but we can work with it, it's fine. And yeah, I would highly recommend, if you want to check OpenTelemetry, to start with a demo. It's a nice way to deploy this locally using Docker Compose or even running on local Kubernetes cluster to get an idea and start with OpenTelemetry. I will be deploying the demo on Kubernetes and using the official Helm charts, which is a way to package Kubernetes stuff and deploy your applications on Kubernetes. You can check it if you want. And in the first part, I will be sending the data to Prometheus and Jaeger. These are CNCF related projects. They are completely open source. You can use them. You might know them already. And metrics will go to Prometheus, and traces will go to Jaeger, and then I will be using Grafana to check the metrics and Jaeger UI to interact with the traces. How this is done, the SDKs are configured to send the data to a gateway, the OpenTelemetry collector, and the collector runs on the same cluster. It's a different application in a different container, and it is configured to send the data using OTLP to two different backends, the Jaeger backend and the Prometheus backend. And on the second part, I will bring down the demo and I will use a different backend. I will send all the data, all the signals to Elasticsearch, and I will check how I can search them through Kibana. In this case, I have all the signals in the same data store, so it's even more convenient because I can do signal correlation easier. And yeah, let's do this. Now it's the interesting part. So I have already installed the demo to save some time. So the command to use is this helm install command. When you will install the demo on Kubernetes, you will see this nice output here, some instructions on what you need to do next. First of all, we need to, because I run this locally, you need to forward the port from the Kubernetes cluster, the containers, to your local machine. So as to interact with this, I've done this already. And here I have some links that I can use. For example, the web store, the Jaeger UI, Grafana, and so on. There are other pieces like load generator that you can use, and feature flags, a thing that you can enable or disable different features to check them through the demo. And it is already running, so I will go and generate some telemetry, some traffic and telemetry. Does it work or? Okay, so I will go and buy some stuff to spend some money on this website. So what I want to achieve here is to produce recommendations. So I will be checking different products so as to get recommendations from the recommendation service. Let's buy something finally. All right, so now if I go to the Jaeger UI, I can find the system architecture here. I have the service graph. Here I can see how the recommendation service interacts with the other microservices, and I can check for the recommendation service and all the related transactions that I can find here. I can find the latency distribution. I can find how they are distributed in the timeline here. I can, for example, check this one, which seems heavy. And yeah, here I can see how the whole trace is organized, the complete transaction with the different spans. And this is the recommendation span, which comes with all the related logs, additional metadata like what is the deployment name, the service name, and so on. Now I will go to Grafana to check the metrics. This is the recommendation rate. And I think we're with time. Still going? Okay. Let's bring this down and try to do the final step, which is to send to Elasticsearch. So I'm using a different configuration here to send to Elasticsearch. I will need to forward the port again because the applications went down. Yeah, it takes some time. While it gets started, yeah, if you have questions, you can check the CNCF Slack. There are some channels that you can visit. Everything is open source, it is community driven, so you can even start like following the project if you want to start contributing to open source. Python special interest group might be something that you need to check. You can check the GitHub projects and start like searching for some first issues that you can contribute. It's a really nice project there. And let's see. It seems that it runs. Let's see how the application, the microservices are doing. Everything is running. Cool, so I saved some time. So I will go to Elastic. I run on Elastic serverless. I send the data there. You can start with a free trial if you want to check everything without paying. And if I go to the service inventory, I will find all the services here. I have a service map as well, similar to the one that we found before in the Jaeger UI. It's not really convenient to find this, but it is here. And let's drill down to the recommendation service. And here I can find a nice overview of the throughput and the latency for this service. I can find the spans, or the transactions as we call them, and I can drill down to this specific type of transaction, the list recommendations, and here I can find how it is the latency distribution for this type of traces, and here I have the trace samples. So I can find the metadata here, I can get all the logs that are related because I can correlate them using the trace ID, so I can jump from one signal to the other and start investigating the application more. And I can also check my metrics. Here is the recommendation. Oh, I forgot to produce traffic, so the rate is not really meaningful, but yeah, trust me, this is I can even, actually I will generate some traffic to see this. Do we have time or any questions while I generate traffic? No? I will be around, so if you're interested.
Do you have any questions? Okay.
Yeah, I just have one question. We are in the process of migrating to Kubernetes and OpenTelemetry. I mean, we are a Datadog shop until now, and we are migrating to OpenTelemetry. Is there anything that can help with Python profiling, let's say? Like, I mean,
Python profiling?
Yeah.
I guess there is support for profiling, and profiling is a low-level thing, so it doesn't matter what language you are running, because profiling tracks on the system level the system calls. And profiling is recently supported in OpenTelemetry. It's not really mature, but you can check this. There is already support for this. And yeah, I think I listed it here on the signals. Profiles are supported already.
Awesome, thanks.
Thank you.
Any other questions, guys?
I guess that's all then. Thank you.
Thank you very much. Hello, everyone. Let's welcome Valeria. She will show us how to build our own cloud architecture in 30 minutes. Valeria.
Hello, Athens. My name is Valeria, and the topic for my speech today is Agent 007, Build Your Own Cloud Architect in 30 minutes. So I'm going to teach you how to make an agent that can manage cloud services on your behalf in 7 simple steps in just 30 minutes of your time. Before we begin the tech talk, I want you to ask yourself a question. What do you not like to do? I want you to think of this question throughout the presentation and share your answers at the end. Today we'll start with my intro, then we'll get to know what is an AI agent, how to make it, and what things to keep in mind. And before we begin, I'd like to know the level of my audience today. So raise a hand if you know what is an AI agent. Cool. Keep your hand raised if you build an AI agent already. All right. And keep your hand raised if you did it with ADK. All right, so we have one pro in the room. Now that I know a little bit about you, I'll tell you a little bit about me. I'm a certified Pythonista, and I also recently became Google Cloud certified. Technically, I like collecting pieces of paper with my name on it. Here's also 2 truths and a lie about me. First one, I've never been to Greece before. Second, I've never had a Greek colleague. Third, I've been reading Greek myths before sleep in my childhood. You can make your bets and check your intuition at the end. And we're also going to have a quiz with prizes, so pay attention and it will be worth it. If to talk about my experience, I started as a freelancer for other companies. Then, when I gained enough experience, I was invited to be a mentor for junior developers. After that, I had a really nice time at an Austrian company called Wigfinda. And now I'm a developer in Google in Applied AI team. Big disclaimer, I'm not talking on behalf of any companies I work or worked for. I'm just sharing my personal knowledge. So what does Applied AI team do? Probably some AI stuff. I would say Applied AI is not about science. It's not about training models or creating them from scratch. It's about using models built by these scientists. And my talk today is about how to apply AI. One of the options where to apply AI is agents. Now, a very important question. What is an agent? Thinking face emoji. So slide 9 is where you get the answer. Most of the publicly available solutions are LLMs or LLMs with RAG. If to make an example, LLM can help you find tips for creating a Kubernetes cluster. An LLM with RAG can help you find exact commands as well as check if there were outages recently. Though both of them will just generate a text-based answer, and that's it. A real AI agent can do something on your behalf. For example, an AI agent will authenticate you into cloud, ask for your preferences, and create a cluster on your behalf. And currently, there's not many true AI agents that can do that. Let's look into details what a real agent consists of. First, we take LLM as a base. That could be Llama, Falcon, Gemma, you name it. Add some memory, short-term or long-term, reasoning chains. Oops. All right, something happened. Just a sec. We are back on track. So LLM as a base, memory, reasoning chains, they help the agent analyze its steps. Usually the models with reasoning chains are called thinking. Then we add some processing tools that could be anything so that it not only works with text, for example, and then we add some external APIs for dynamic data flows. Before we had to initialize all these components one by one, but recently there was a release of Agent Development Kit, and believe me, it's a game changer. What ADK is an open source framework for developing and deploying AI agents. It can be used with popular LLMs and GenAI tools. It's model agnostic, deployment agnostic, and it's built for compatibility with other frameworks. It supports complex agent architectures and orchestration. And this framework is what we're going to use today during the tutorial. All right, let's do a quick warm-up. Raise a hand if you're using ChatGPT. All right, raise a hand if you're Team Gemini. All right, Team Claude Anthropic. Cool. And Team Too Cool for AI. No one? All right. I'd also like to highlight that it's extremely important to pick the right model that specializes on your needs. For some cases, small models should be enough, but for complex ones, it's better to use larger models. Just a sec. Most of the AI models are available in different sizes. For example, currently on olama.com, a website with models for downloading, there's 182 models available. These are the most popular ones on the slide, and as you can see, models have different sizes, and that's indicated by a number of parameters. A number of parameters means the number of learned weights and connections in neural networks. So the more parameters generally means greater model capability, better performance on complex tasks, but also higher compute requirements, more memory needed, and slower response time. If you choose a weaker model, you might end up with something like this. Obviously, that's Photoshop, but it had similar vibes to what I got at early stages of development. And here's a sneak peek of how well it can go. As you can see, the agent ran a script for authentication. It opened a web page for me, I confirmed, and I was logged in into cloud. And now we're moving to a tutorial so that you can see the screen on your laptops as well. So let's start the 7-step tutorial, and at the end, I'll give you a link to this project on GitHub. Step 1. We'll create a virtual environment to isolate for the case if something goes wrong. Then we install all the needed packages, that's ADK framework and LangChain community. Step 2. Now we have the setup ready, we can draft an agentic LLM service. Previously, we needed to initialize the memory, conversation chain, reasoning chain, and many other tools like UI to interact with the model, but now it's done seamlessly thanks to ADK. Step 3. To interact with the model, I chose Gemini. We need to get the API key from Google AI Studio. All you need to do is just click the button. It's free and no need to add your card. If it exceeds the limits, it will just stop. After getting the API key, you can check that Gemini API is enabled, and we can start using the model. After getting the key, we'll put it in the .env file in your project. And you can skip this slide if you're using a different model. Here's what we have so far. As an example, let's see what components we get in WebUI out of the box in ADK. This is built with Fast API. In the events, you can see, oh my God, I'm sorry. Is it good? All right. So in the events, you can see the current conversation chain. Then there's state, artifacts, and previous sessions, and it's all reset when you stop the server. This menu is foldable, so you can make the chat bigger. If you enable token streaming, or create a new session, or delete the current session, it will work as well. As for the communicating with the model, it allows text input, voice, video, and attachments. Currently, we're at the stage of pure LLM. It doesn't have any tools, so it gave us some tips how to create a cluster. And if you get carried away with prompts, you will see this friendly error at the bottom of the chat. I got it, and I was not charged. It just stops working if you exceed the daily limits. Step 4. Let's add search tool to the agent. Just import a built-in tool and we are all set. It calls Search API under the hood. There's also other built-in tools except search. There's code execution, vertex doc search. All you need to do is import them and add them to the tool list. And currently for each root agent or a single agent, only one built-in tool is supported. And I will show you later what to do if you need several of them. Here's how search usage looks like. The LLM was not trained on the data that contains the answer for what's the name of Lady Gaga, so it had to use the search tool. I didn't tell the LLM to use the search tool, instead it made this decision on its own. So even if you don't learn anything about agents today, you will learn that the real name of Lady Gaga is Stephanie Joan Angelina Germanotta. To add more tools, we'll use tools from LangChain. That's a cool open source library with a lot of stuff inside. I've listed some of the LangChain tools as an example, but there's tools for anything you can think of in the LangChain documentation. Step 5, let's actually add one of these LangChain tools. As an example, I added Shell, but you should never try this yourself at home. AI might hallucinate and hack your computer. Even though I kind of limited the tool too, it's still dangerous to use the shell tool on your local machine. Step 6, we need to download and install Cloud CLI for terminal. I decided to use Google Cloud, but you can use any other Cloud CLI. Here's the link for it, and once it's downloaded, you just need to run the command in your terminal, and if you use a different cloud, skip this slide. Step 7. I actually lied when I told you that we'll make an agent today, because actually we will make 3. In ADK, it's better to isolate tools into different agents. Therefore, we created a separate agent for the search, for the shell, and agent orchestrator to manage them. And as this is the last step of building an AI agent, I wanted to show you an example of multiple tool usage by the agent. The prompt is, check my macOS version and search online if it's the latest. The model checked my OS version by a shell command, then it searched the web for the latest available, compared the responses, and gave me the answer. You can also see in the event details on the left, it's great for understanding what's happening under the hood. Wait, is that it? Do we really need just 39 lines of code to stop searching for commands and have an AI agent for it? Yeah, that's the whole code. In our project, we can already have the API key for the model. We already can make prompts. If the LLM was trained on the data, it will just execute the command itself. But if it was not trained, then it will search for it and execute. So it's showtime. I've prepared a demo for you where the agent creates a Kubernetes cluster, so take some popcorn and enjoy. First, I'm asking, how many Kubernetes clusters do I have? The agent is calling the tool, and it failed. So let's start again. Now I'm restarting the agent. And I'm asking what's my current GCP project. And it says that I don't have a project set up. So I'm asking to set this one as the default one. It's executing the tool again, and it says that it was set, but I usually don't trust AI, so I'm checking manually if it was actually set. And it was. So now I'm asking how many Kubernetes clusters do I have? It calls the tool, and it says that I have 2 clusters in running state. I'm asking if they are in one fleet. It is checking. And it says, yes, they are both in one fleet. I'm asking if there were any warnings about them. It calls the tool again, and it says that it was not able to check if there were any warnings because it tried to do that for both clusters at the same time. So then it decided to do it separately per cluster. Just a sec. So it's checking separately per cluster. And it says there was no warnings for them. I'm asking to create one more cluster so that it triggers cluster update for them. For example, a cluster with old version, because clusters with old versions should be upgraded.
I think it's power management. Probably power management does that. You should plug it in.
What do you mean? All right, so yeah, it created a cluster for me, so maybe let's move on. So here's a link for the project that we've built today, and you can play around with it. Maybe some of you will even turn it into a successful startup. If so, just send me the offer and I'll join your team. It is not the end of the talk, sorry. I just wanted you to have time to take a picture. But yeah, for this project we built today, we also need to add security mechanisms before deploying to production. Otherwise, one day you will wake up and find your creation on a Reddit page called AI fails. If you need a proof that your job is safe from being taken by AI, here's an example. By the way, there's a nice talk about security mechanisms in RAG right after me in this room. As for this slide, I prepared two versions of it, for Gen Z and for millennials. As I can see, today we will go with Gen Z slide. So important things to keep in mind when developing an AI agent is not to be sus about your user data and data policies. You should also test it a lot in all possible test variations, because prompt injections are no joke. Also let your users know the limits of your AI solutions and give them the ability to correct the data. When deploying, start small, scale when ready, keep your hand on a kill switch just in case, and catch biases before they catch you. You should always comply with regulations, even though they can be sometimes a headache, and create ethics guidelines as well as a tool for gathering feedback. Here's also a list of ideas what I came up with for agents. All these tools take a lot of my time, so I'd be happy to delegate them to AI agents. As a bonus, I decided to also share my take on vibe coding. For those of you who don't know what it is, vibe coding is a software development practice that uses AI to generate functional code from natural language prompts, and it makes app building more accessible, especially for those with limited software developing experience. I'll start with a story. So when I was back in the university, I used to copy my friends' coding homework and run it. It worked, and it was convenient, and it also gave me enough time to learn coding at my own pace. Vibe coding is similar to that, because you get code for your needs without much effort. And vibe coding is great as long as you read it and test it. If I was to build a graph of reliability and time spent, I'd put vibe coding here. It's fast, but I'd rather not use it in production. Then manual coding would be here. It's more reliable just because if a person can write code, it can also fix it when it fails. Manual coding with tests would be much higher, and you won't be able to push something that breaks previous state because of the tests. And I would put vibe coding with tests here. The test will guarantee that you'll get the same result as you would get with manual coding with tests, and the tests, and it will also save you some time. All right, let's summarize with a slide we already saw. An AI agent consists of LLM as a base, memory, reasoning chain, processing tools, and APIs. First three are included into ADK agent, and you just need to add description and tools. For this slide, I posted again a QR code to the project we've built today. So when you go home, clone this repo and vibe code a prototype for something fun. Phew, now we reached the additional resources section. Here I listed ADK docs. That's a great starting point with a lot of useful info to go deeper into agents. And you might also be wondering, hey, what's this game on the right? And it's actually not a game, but it's a scientific paper by scientists from Stanford, Google Research, and DeepMind. They took 25 agents, put them into a simulated world, and watched them behave like humans. It was super easy to read, so I highly recommend it. And the last one is a blog by Simon Willison, and I especially like this one called Hallucinations in Code are the least dangerous form of LLM mistakes, but I will not give any spoilers. And now we reach the quiz section. So please open the browser and we'll play it. So if you go to quiz.com and you enter this PIN code, you'll be able to connect to the session. You can use the Wi-Fi of the venue, and no need to open your account. You can just log in as a guest. So in this quiz, we will have short time per question. The faster you answer, the more points you get. And at the end, 3 people will get prizes. If anyone is watching on the live stream, you can also connect, but sadly, we can only give prizes to people who are here in the room. All right, so I see that most of you connected, so let's start. Question 1. Which of these creates human-like responses after being trained on large text datasets? Yeah, LLM is the right answer. Question number 2. Which of these searches information in external data sources before answering a question? All right, so it's RAG. So in the first place, we have Lady Heat, then Lucky Wasp, and I was not able to read the third. Question number 3. Which of these is capable of autonomous actions such as using tools or interacting with environments? All right, so it was AI agent. Lady Heat is still in the lead. Lucky Wasp and Sister Woman, good job. What is the name of the solution that can help with making an AI agent? Please type 3 letters. Doesn't matter if they're big letters or small letters, whatever. So the right answer is ADK. All right, the situation changed. Question number 5. Select steps you need to do to create an AI agent. Order doesn't matter. So it's one of the questions when you can have multiple or even non-answers. But in this case, all the answers were correct. All right, Lady Heat, AG, and Foolish Eyes. Good job. Question number 6. Which of these can be called by AI agent using shell tool? The right answers were Cloud CLI and Git.
So Lady Heat is amazing, yeah?
Yeah, Lady Heat is still in the lead, AG and SO. Next question. What is the name of the framework that contains a lot of pre-built tools for agents? Is it LangChain, LangLeap, LangQ, or Language? Yeah, it's LangChain. Good job. All right, so the leaders are still in the lead. Which of these considerations you need to keep in mind when building an AI agent? Again, it could be none, several, or all of them. So everything except being sus about user data. Did anyone get it right? Oh, yeah. Oh, no. What is the technique when an attacker modifies the prompt to manipulate LLM into producing unintended responses? The right answer is prompt ejection. And the final question for double points, so the situation can change drastically. The order of actions when vibe coding. You need to reorder these steps. And then click submit. So first thing you do is you prompt a question, then you read the generated code, add the tests, and only then push the prod. All right, let's see who is at the top. So we have So on the 3rd place. We have Jolly Aimbot on the 2nd place. And we have Love Nut on the 1st one. Do we have all of you in the room? Could you raise a hand? 1, 2, 3. Cool. Good job. And there's also a leaderboard. So I hope you enjoyed the quiz. And I hope you enjoyed the presentation. Now it is the end of my talk. And
thank you very much, Valeria. Unfortunately, we don't have time for questions.
But you can catch me after the talk. I'll be outside.
Thank you again.
Sorry, just a quick information from me. If anyone from this side of the room wasn't able to scan the QR code, I posted it on the Discord.
Okay, so hello everyone. Next we have Sohan. Let's give him a warm welcome. Sohan, we will talk about securing RAG pipelines with fine-grained authorization.
Yeah, thank you. So yeah, my name is Sohan. I live in Amsterdam. I've worked in the industry for 16 years now, so I've seen a lot of changes. And today I'm going to talk to you about security, authorization, AI, and a bunch of other things. Just as a point of note, I work in a startup called AuthZ, and we work with a large AI company that I'll mention towards the end. And what you'll see today are some learnings from that. So what you're seeing actually is in production. Now, some of you all might have heard of this thing called AI. I don't know if you may have heard of it. And I like to think of 2025, this year, as the year that all of us are putting AI in production. I work with a lot of enterprises, I work with cloud companies, and finally people, after trying out proof of concepts and experiments, are putting AI in production. And they're doing so via agents. We just saw the previous talk, via things like MCP and LLMs, and also this thing called a RAG. Now, if you're not familiar, RAG stands for Retrieval Augmented Generation. So this is when it's an architectural decision. So suppose you have a large corpus of documents, say 1 million documents, and it would be domain-specific knowledge, so something that maybe a regular LLM doesn't know about. So instead of training your own large language model just to read those documents, you can augment an existing LLM with these documents using something called a RAG. And we're seeing enterprises and companies use it both internally and externally for chatbots for, information that might be just in that domain. But what we're not seeing enough of is the security around who can access which of those documentation. Now, anyone here works in enterprise, you may have heard of this foundation called OWASP. Has anyone heard of OWASP? A few of you all, yeah? Excellent. Which means you'll have checked in code at some point of time in your life. And OWASP is an industry body. So every few years, they make a list of risks to web apps or risks to LLMs. And they came up with a list to risk for LLMs last year. And that included things like sensitive information disclosure, where you would ping an AI agent something, and it would give you information that it wasn't supposed to know. Or excessive agency, where you asked an agent to do something, but it did something else again that it wasn't supposed to. And also vector and embedding weaknesses, where I could add code into my vector database maliciously, and it would do something that it wasn't supposed to. And all of these can be addressed by proper authorization. So that's what we're here to talk to you about. And this is typically what a RAG pipeline looks like at a very high level. So all the way to your left. All the way to your left is this is the first phase of ingestion of documents. So you have a big knowledge base, millions of documents. You pre-process it. You clean it up a little bit. Does this work? Yeah, I don't know if you can see it, but you pre-process it, and you send those documents into something called an embedding model, which creates embeddings. Very, very high level. Embeddings are a way to represent words and images in numbers, because computers like numbers. And those embeddings are stored in a vector database. And here's the important part. You can store metadata. So you can say that this embedding came from this document with document ID 123. And remember that, because we're going to come back to that. The second phase looks pretty simple and quite self-explanatory, which is the query, the retrieval, and response phase. So user at the bottom makes a query. And that query also goes to the embedding model. And that embedded query goes to the vector database. And you get all the relevant embeddings, which are then sent to a large language model, which gives a response back. The one thing that's missing from all of this is authorization or security. What if a user accesses some knowledge or some data from that knowledge base that they don't have access to? That's what we're talking about. So I'm going to give you a very quick primer on authorization. In the industry, sometimes people conflate the word auth to both authentication and authorization, and they're two different things. Authentication is identity. So when you log in, who you are, that's authentication. Authorization is permissions. What do you have access to after we know who you are? And in the past, way back in the past, we started off with something called an access control list. Think of it as a very long list of saying, document ID 1, these are all the people who can read this document. Now you have a new list for all the people who can write to this document. Not the most scalable way, of course, but we changed it around in the industry to something called a role-based access control. Again, you, I'm sure, have this in your company where you are tagged to a role like software engineer, and everyone in that role of software engineer can check in code. Someone else is tagged to a salesperson, and a salesperson can access finance reports. So you're putting people into roles, and roles can do things. Again, doesn't necessarily scale, because what if you have one person in sales who wants to check in code? Doesn't happen often, but it could. So it evolved to something called attribute-based access control, where everything is an attribute. So your name, your time of day, your email ID, your location, all of those are attributes. And when a decision has to be made, basically you check if all of the attributes match what is allowed and what's not, and a decision is made. Again, pretty flexible, but at scale can be difficult. Now, after the advent of social networks and sometime in the mid-2010s, Google basically decided that a lot of these don't necessarily scale for their levels of scale. Google has planet-level scale, billions of users, millions of checks per second. So they rethought how they did authorization internally. And we know exactly how they did it, because in 2019 actually, so it's quite recent, they published a white paper called Google Zanzibar. And this is going to be the crux of today's talk. And in this white paper, they describe exactly how Google does authorization across all of their services. If you've ever used a Google product, which I'm sure you have, then in the back end, this is how an authorization check is happening across Docs, Maps, YouTube, Photos, all of it. I would advise you to read the paper. It's about 14 pages, and it's written in plain English, not very academic. It's a fun read. And it describes their internal authorization system, how back in 2019, it could do more than 10 million client queries per second. And I'm sure that number has increased even now. The cool thing is, for a developer in Google, it's just an API. So you don't have to worry about how it works, and I'll talk about that. But it popularized this concept of RBAC, what you see there, which stands for relationship-based access control. So instead of everything being fit into a role or an attribute, everything is in a relationship from one thing to another. So for instance, you can have a user named Gru, and you have a folder named Evil Plans. There's a relationship between that person and the folder, in which case it's viewer. Now say there's a document called Steal the Moon. There is a relationship between the folder and the document, which is it's contained in the folder. And thereby, there's a transitive relationship between the person and the document. So everything is in a form of a relationship. So what can you have relationships with? Well, one is a user. Again, in Google, if you have an account, you have something called a Gaia ID. So that could be your Gaia ID. And that could relate to any object. It could be a folder, a document, a map, a YouTube video, and so on. And the relation could, again, be anything. It could be a member of a group, or an uploader of a video, or an editor of a document. It doesn't matter. So you have a user, you have an object, and you have the relationship between those two things. So once you have that, you need a way to represent this relationship in a system. A computer needs to understand this. So Google described this thing called a tuple, a relation tuple. And the format basically is you start at the hashtag and what's on the right. So you will see user number 3 is an owner of document 123. So say I'm user number 3 and I create a document in Google Docs. This will be written to their authorization system. So that way, the system knows that I am the owner of this document. And this is very flexible, because objects can also relate to other objects, and objects can relate to other objects' relations as well. So for instance, in this, again, start from the right, the group security is a member of the group engineering. Now this gives flexibility for Google when things change. Imagine when you have a reorg at work and say suddenly group security reports to the group DevOps. Internally, there's a whole lot of changes for your LDAP and for your groups and so on, but in a Zanzibar-like system, it's just about writing a new relation tuple. So we have users, objects, we have relations, we have these tuples. What is done with all of this? Basically, the backend builds what is called a directed acyclic graph, which represents these users and the relations. So say you have a document, and you have users. Fred and Kim are readers of that document, and Jill is a writer of the document. You will notice the key here is this little dotted arrow between reader and writer, which indicates that everyone who's a writer can also read the document, again, like in Google Docs. And this gives flexibility. Say suddenly you have to add an organization into this mix. You just add a new node to the graph, like organization, and you say this is the name of the organization. You have an admin, say Niv, and again, look at the dotted line between writer and admin. So this indicates anyone who's an admin of an org is a writer of the document, and we know all writers are also readers. And anytime now, say a permission checks comes in. So say in the backend, at any time, if you have tried to access a Google Doc, this is probably what's happening. So the check comes for checking if Jill is a reader of some document, right? So Jill clicks on a document link. Do we know Jill has access or not? Basically, if you can traverse from the document to Jill in a unidirectional way, there is a relationship. So let's take a look. Here you go from document to reader to writer to Jill. There is a way to traverse. So the API returns saying, yes, Jill has read permissions. Similarly, if you want to check if Fred at the top has write permissions, there is no way to go from some document to writer to Fred in a unidirectional way. So Fred does not have permissions. So again, anytime you have accessed a Google Doc or any file on Google, this sort of check is probably happening on their system. And this is new, 2019. It really set the authorization and IAM world on fire, and lots of companies are re-architecting their authorization for this because it is designed for scale and for low latency. It has to work at Google scale, and especially when things change a lot. The relationships between users and documents and objects change a lot, which is what happens. This Zanzibar-like system really shines. Turns out, a RAG pipeline needs all of these requirements. It's a lots of documents, it's users, it's low latency, and hence we're going to use a Zanzibar-like system to secure our RAG pipeline. Now, this came out in 2019, so there were lots of open source versions of Google Zanzibar. I think the most famous example of Google white paper going to open source is probably, can anyone guess? Is Kubernetes. So Kubernetes started off as Borg in Google as a white paper and internal system, and then of course people built an open source version, and now the whole world uses it. So right now, these are probably the 4 most popular open source versions of Zanzibar. There's SpiceDB, Ori, OpenFGA, and Permify. The company I work for helps maintain SpiceDB, so I'll show the demo with that. But it's an open source project with contributions from Red Hat, GitHub, Netflix, and so on. Feel free to jump in and contribute as well. And the only metric I think that matters to us as developers is GitHub stars. That's the only metric we check. So yeah, it has about 6,000 GitHub stars. Could always use more. So nudge, nudge, wink, wink. And that's what I'm going to use in our demo. So what is SpiceDB? Well, SpiceDB is an open source implementation of Zanzibar. In a way, it's a graph database, and it's optimized for purely authorization queries. So if you want to build authorization into your app, you can use this open source thing called SpiceDB. And you can make queries in any of the client libraries, but internally, it's written in Go. How does it work? Well, there are 3 things you need to know. The first one, remember when I showed you the relationship tuples? Well, before that, you'll have to do something called a schema. Again, this is described in the Zanzibar paper, but a schema is a way to represent any use case. So your use case could be something like YouTube or like GitHub or even Google Docs. How do you represent the users, the objects, and the relations in them? Well, say you're building something like Google Docs or even a RAG pipeline. you have objects like a user and a document, and you have the relationships between them, like a writer of a document can read and edit a doc. In schema, basically, you're just representing it this way. You're defining the user and the document, the relation between the user and the document. So a user can be a writer or a reader, and if they're a writer, they can read and edit a doc. If they're a reader, they can only read the document. Yeah, so you describe your use case within this schema. Once you have the schema, you can create, read, update, and delete relationships. This is what I showed you. So anytime a new document is created, you add a relationship between the document and the creator. Anytime someone is added to a document, you add that as a relationship here. So in this case, we have a reader who's Fred, a writer who's Jill, and suppose a new user like me, Sohan, is added. I will be added to, say, the writer of the document. And again, this additions is done via the tuple that I told you earlier. And lastly, you have to check for permissions, of course. We have a schema. We have all these relationships. When someone tries to access something, you check if they have permissions or not. So this is the same old graph that I'm showing you. So you can check for permission. Again, remember, unidirectional way from document to someone. SpiceDB also gives you lookups. So you can look up a subject and say, give me all the readers of some document. So it will traverse this entire graph and give you all of these names, because all of these people are readers of the document. You can also do a reverse lookup and say, give me all the documents that Fred can have access to. So in this case, you would get some document, but in a real-world scenario, this is a massive graph, so there's a reverse lookup in all of these documents. All right, so we have RAG pipelines, and we have a very new form of authorization that is well suited for RAG pipelines. Let's actually jump in and see how that would work. There are two techniques or two different ways you can do this, a pre-filtering and a post-filtering. So I'm going to start with something called the post-filter method. So far, so good. This is our standard RAG pipeline. You have an embedding, you have vector databases, and you have the metadata. Remember? Callback? Yes, you have the metadata in your vector database. Once you get that, you can actually use any Zanzibar-like system to run check permission requests on each of those documents that come from the embeddings. So say you get back 5 embeddings with 5 different document IDs, you can run a check permission request on each of them to see if the user has access or not. And say maybe the user doesn't have access to one of them, that's great. The other 4 will be sent to the LLM and a response is sent back. So this way, the user is not seeing any information that they don't have authorization or access to. So you get the embeddings, you look at the documents related to those embeddings, and then do a check permission request. Typically, you would use this method if you have a high positive hit rate of the user having access to documents. Say you have 1 million documents and the user can access just 2. This is a very inefficient process then. But say you have 100 documents and the user can access 90, this is the way to go. So when a post filter is inefficient, we have a pre-filter authorization where the user makes the query, and even before going to the vector database, you do a pre-filtration. So here, instead of a check permission, you are going to look up all the documents that the user can have access to. So you do that lookup request, you get a response, and then you send those embedded with the query itself to the vector database. So in the beginning, you're like, give me all the documents that the user can access, and I will only use those in the vector database, and then go to the LLM. Here, if you have a very large corpus of data, like 1 million documents, maybe the user can access 100, this is a much more efficient method. The demo I'm going to show you is this pre-filter authorization, and I'm going to show it with using PyCon as our vector database, with the OpenAI API, with SpiceDB as our Zanzibar-like system. But honestly, you can swap it out for any other tool. You can use a different Zanzibar-like system instead of SpiceDB. You can use pgvector or any vector database, and you can swap out any model. And I use LangChain to chain all of these. So let's go. If you want to, the entire demo in a Jupyter Notebook is on this link. So if you want to take a photo, maybe now's your chance while I get a sip of water. I'm also going to make a quick prayer to the demo gods, because conference Wi-Fi and demo, you know how that goes sometimes. But we will see. Okay. So this is my Jupyter Notebook. I hope you can see it at the back, but yeah, it's good. All right. Okay, maybe I'll increase it a little more. So first thing is I have a local instance of SpiceDB running here on my screen. So it's running locally. Typically, of course, this would be running in the cloud. All this is just boilerplate code. But first, we start with defining our schema. Right? This mirrors our use case. Super easy. We have a user, and we have an article, which is in our RAG pipeline. And we need to define the permissions and the relations between them. So the relation is a user can be a viewer, and if they're a viewer, they can view it. This is the easiest possible schema. Of course, in production, you can add a relation of a user being a writer to this RAG pipeline, whatever. Right? So I'm going to run this. So I'm writing the schema, and you will see here at my system clock is weird, don't mind that, but you can see a write schema request that's been made just now. Right? All right. So now what I'm going to do is I'm going to write relationships between some documents and the user. I'm assuming a user is logged in named Tim, and I'm just going to create two documents, again, very simple demo. One document with ID 123, one document with ID 456. Right? So we have two documents, one user, very simple, and we are adding the relation of viewer. Right? So I'm just going to write that relation to my SpiceDB, and you will see these relationships have been written. Okay, so I've created a Pinecone index already as my vector database. You will see it here. This is my Pinecone database. I'm not going to create it again. And I have also added embedding. So these are my documents. Typically, this would be some, like an S3 bucket or OpenSearch where you have millions of documents. But for the demo, I've created two documents, and I've added random stuff into it. I've said, Bill Gates won the 2025 Oscar for Best Football Movie. There's no such thing. And the revenue, whatever. It was just for fun. But the important thing, the article ID of this is 123, and the article ID of this is 456. Right? And I'm just initializing a LangChain embedding, where I've added these embeddings into my index already. So, oh, I haven't. I'll just run that now. Yeah, so I'm just going to run that now, and that should write to my Pinecone database. Yeah, there we go. It's written to my vector database. So now I'm running that lookup request that I told you about, this step where I'm going to get the documents that the user has access to. So let's run that. And I get back from SpiceDB that Tim is authorized to view two articles, 123 and 456. And you can also see this permissions request that's being made, a lookup resources in my local SpiceDB. So now that I've got these two documents, I can actually tell my LLM what I need. So I'm defining a LangChain object to talk to OpenAI. Using an older model, you can swap it out to any model. And this is a Pinecone index with my OpenAI embedding model. I'm initializing a retriever with a filter. And this filter is the documents that I'm allowed to view. And this part here is just basic prompt engineering, where I say just answer the question using the context below. And the question I'm asking is, who won the Oscar, right? And that information is there in document 123. So yeah, it pinged the OpenAI API, and it gave me that information, right, from that document. I can also do a summary. I can also do a summary of only the articles that the user is allowed to view. So right now, the user can view both articles. So I'm going to run a simple summary. Again, very similar things with the prompt engineering and some LangChain object. And you'll get, let me run this summary here. So yeah, it says Tim can view articles 1, 2, 3, and 4, 5, 6. And it's making a call to the OpenAI API and says, yes, in Q4 2025, the revenue was 1 billion. Additionally, whatever, right? So it summarized the 2 documents the user has access to. In the real world, these things change. So for instance, maybe someone has removed Tim's access to this article 1, 2, 3. So you can see I'm deleting this relationship between Tim and that article. That's what's running here. So I'm just going to run that. You will see here a write relationship call has been made. And we can actually check and see that, OK, right now Tim can view only 1 article, right? And let's make that call again. We'll say, OK, who won this Oscar? The LLM says, I do not have context on this because Tim does not have access to that document, right? Earlier, we asked the same question when Tim had access, and we got information back. So that was basically it. Now, this, of course, is a very, very simple demo, 2 documents, 1 user. But I'm happy to tell you that this is literally what OpenAI uses for their connectors product. So recently, OpenAI released a new product called Connectors, where you can connect it to Google Drive or Dropbox or a bunch of other tools, and you can query data from that. And they use SpiceDB, and of course, at a much, much bigger scale. But all of it is basically just horizontal scaling. You have beefier compute, beefier databases, and so on. And yeah, they're able to process 37 billion plus documents and fine-grained authorization for each of these using what I just showed you. And you also have second-order effects where you do a thing, but there is another effect of the effect, which is one, you get audit logging for everything. So anytime a permission changes, you have to write that to the database, so that is logged. And of course, you're optimizing your query responses as well, because you're querying only documents that the user has access to. So you can also optimize your RAG pipelines at scale. Anyway, I think I'm almost done with time. So again, if you just want to take a photo, the first one is a link to the workshop. I suggest if you like things like distributed systems, read the Zanzibar paper. It's a Google white paper, very interesting. And yeah, check out SpiceDB. Feel free to jump in and contribute. It's open source. And yeah, I'm around for any questions. Also, feel free to connect with me on LinkedIn if you have any other questions. And hope you learned something new today. Thank you.
Thank you very much, Sohan. Do you have any questions?
Yeah, quick question. The SpiceDB, if you go back to the diagram, from mine, the next one, another previous one? Yeah, that one. From my understanding, you have to maintain 2 databases, right? Like a PyCon or a vector database and SpiceDB. And each time you upload like a new document, you have to also state the, the auth and stuff like that. So are there any like plugins or like extensions to existing vector databases to connect SpiceDB, let's say, to have everything in one place and not maintain 2 databases?
Yeah, that's an excellent question, very astute observation. A big, like a hurdle, I'd say, to implementing something like this is there is complexity, right? And the big complexity is in what you mentioned, in which you have to write pretty much to 2 databases, and it's called dual write. So anytime a document is added, you have to add it to PyCon, and you have to add that relationship to SpiceDB. Now, we've been working on something called a foreign data wrapper for Postgres, where you can just read from your Postgres database. And so potentially you could use something like PG Vector, which you use Postgres as a vector database, and you use your foreign data wrapper. So then you're just writing to Postgres, and that is the source of truth. So it's not live yet, because that is also very complex. But right now, if you have to implement it, this is the method. You're doing the dual write.
And do any, because you showed SpiceDB, okay, and you also showed some 2 or 3 alternatives. Do they provide like an extension?
To the best of my knowledge, no.
Okay.
Because all of these, like I know, for instance, OpenFGA, which is the one that you saw on the rightmost, the colorful logo.
Yeah.
They also, because I've read dual write problems on how to solve it in their docs. right? So you have to do that.
Okay.
It is how the system's designed.
Yeah. Okay. Thank you.
Any other questions? Okay, so that's it. Thank you very much, Sohan. Okay, so lunch is served in the sponsor area. Also, PyLadies lunch is happening in Innovathens, first floor. Yeah. This open space is a welcoming space for women and non-binary people in the Python community to come together, connect, and build meaningful relationships. Thank you very much.
Okay, everyone, welcome back. I hope you enjoyed your lunch. So in the next talk, we have Christos, and Christos will talk to us about ETL beyond Spark. So let's give him a warm round of applause.
Hello to everyone. Thank you for joining. And those watching us online. My name is Christos Georgoulis, and I am data engineer at Witside, a boutique data agency here in Greece. We help businesses handle their data. We often build a data platform from scratch or even help them optimize their own. Most of the times we use what it is considered industry standards. And we got good reasons for it, because there is good community, there is products and platforms that have nice and shiny features to help us stay organized. So we work with those tools. But we have to challenge those decisions, those tools, and see if we could become more performant, both technically and financially. So this is the topic of this talk. We'll start from the promise of the big data is coming from the past decade, and we will talk about the tools that the ecosystem offers us to handle what is more relevant to day-to-day work, smaller data sets. We put them into a test against a real-life pipeline and discuss the results based on some performance metrics we want to use in order to evaluate them. And we're closing with my last 2 cents on the topic. So let's get back a decade. We are in 2015. The big data hype is on, and most pitch deck opens with a slide like this. This is actually from back 2015. So everything after that is a projection. So the quote is that big data is coming, and the message underneath is that we have to do something about it. We got to be prepared for it. Just a year before that, we got the launch of the first release of Apache Spark, which is actually an engine for processing big data. It deals pretty well with huge data sets. So we got the upcoming need, we got a tool. So say no more, I got you, right? Fast forward to the day, based on our experience, the vast majority of data sets are not into this category, are not under the category of big data. Even though we produce lots of data sets, each one of them is not under this category. We have some of them, but most of them are not. This is something highlights Mr. Jordan Tigani, which is the founder of MathDuck and former engineer of Google. He worked on the BigQuery. He posted a blog post with the title "Big Data is Dead" back in 2023, and he does some points. 2 of them are that most probably you are not producing big data, and even if you do you really need to process them? Because what we're talking about data anyway, we want to support our decisions. So in order to make better decisions, do you really need to process those huge amounts of data that you are producing? And he concludes with this quote that big data is real, but most people may not need to worry about it, which makes perfect sense based on our experience. So, though Mr. Tigani focuses on the OLAP databases systems. So let's see where that falls into the journey of data. So on very high level, this is the typical journey of data. We start from the data sources, and through a process, the data ingestion process, transfer them into the landing zone. The landing zone exists in a system that may be a data warehouse, that may be a data lake, or even a data lake house, which is actually a data lake with extra layers. So from there, from landing layer, we transform those data in order to do to make them more relatable to business domains, and land those transformed data into processed layer. So in that data transformation step, it may include some joins, some calculations on columns, or data types, and things like that. So if you do a good job in data transformation process, you got a very good processed layer on top of which we can run our analytics queries. This analytics queries is the part where we extract insights from our data. And this process feeds actually the business intelligence apps and ML apps our end users consume. So this, I say again, on very high level, this is a typical journey of data inside an organization. So Mr. Tigani focuses on that part, the analytics queries part. So what he notices is that on the process layer, usually we don't have that much of data. And the process layer is where we got typically lots of data because we want to keep our history there. We want to notice the trends or the patterns. So the question is, okay, we understand what Mr. Tigani said, but what about the data transformation step, which is the step that feeds the process layer? Most of the times we use here Spark to handle the data transformation step, even if we don't have big data, because some of our data sets are big. So we have set up a data platform that can handle this load, but the other data sets are not big data. So we don't need to process them with a big data tool. But even those big data data sets, could we handle them in a way to make them into smaller pieces in order to handle them as small data? And the answer is yes, we can do that. We've got two approaches on this step, the full load and the incremental load. The full load is a process that we use the full history of our data in order to process them and update the process layer. It has its pros so that it is easy to implement and maintain. It has no major performance impact for smaller data sets to process them that way. But it actually doesn't scale well on bigger data sets. And we spent compute even small amounts of it in order to do the same processing over and over again. Think of those color tiles as once dates data. So once you process one tile, the next day you got to process it again in order to update the processed layer. So the other way is to do it in incremental load. So with this approach, you use only the latest increment of data in order to update the process layer. On the pros, of course, we've got a lot of smaller data to process. We process the data only once, and the processing volumes stay constant over time. So why we don't use it every time? Because it's a little bit harder to implement and maintain. And when you use big data tools to process smaller data sets, it oftentimes has worse performance than the full load approach. Okay, if we say that we will not use a big data engine to process them, we could break down our big data sets into smaller pieces and use incremental load to process them on the data transformation step. So even if we got big data to process, we can break it down into pieces and use the incremental load approach in order to do our transformation. So we got the approach to break our data sets into smaller pieces. So we got to see what the ecosystem has to offer us for tools in order to implement the data transformation process. So here is the Git repo start history of 3 tools, the Spark, which is, as we said, the industry standard at the moment. With the blue line, there is a DuckDB, and on yellow line, the Polars. They are very different tools. We will see them in a moment, but we see that they gained some traction lately. So let's see what they are. First, let's clear it out what Spark is all about. Spark is a distributed big data engine. It uses big clusters and break down the big data sets into smaller pieces, spread them into the nodes. So each node processes a little piece of the data, so the processing happen in parallel. So pretty much this is the idea behind Spark. It can handle massive data sets on a terabyte and petabyte scale. It has a rich ecosystem. It has a flexible deployment, and also its maturity is very strong with a wide community around it. On the other hand, we got Polars, which is actually a colorant data frame library. Think of it like pandas on steroids. It's built on Rust, so we got good performance, and it's optimized for single node and multi-core processing. It does great with smaller datasets, and it has a Python API, which feel very familiar for those who are already working with PySpark. I didn't used to use Polars. I used it only for the test, and I felt really confident very fast because of my experience with Spark. So lastly, we got DuckDB, which is actually the SQLite for analytics. It's an embedded analytical SQL engine. No server needed. It's super lightweight. It's designed for roll-up workloads and scale very well locally. It has a good integration with Python, R, Pandas, Polars, and Arrow. So we got 3 totally different systems that no one would even dare to compare them, but each one of them can be used to implement the same job, the data transformation step we talked about earlier. So the idea is that we want to run the exact same pipeline with all those 3 tools and see what happens, right? So we need a pipeline first, right? So TPCDI, it's a benchmark for data integration pipelines. It offers us exactly that, a pipeline to make our test. This is a diagram from the benchmark itself. It shows pretty much what is happening here. We got raw data in various file formats. They live in a staging area, and we transform them with joins and type conversions and things like that in order to update the data warehouse. So this benchmark is designed for OLAP databases, but we're going to use it on our own setup. So this is our setup in terms of the storage. The staging area is what we so-called earlier the landing layer. Those data are in a data lake in the file format given from the benchmark itself. And we don't use at the warehouse, we use the data lake again, and our tables are in delta table format. So this is the so-called process layer we got earlier. OK, so we got our storage. Let's see the compute. So for compute, we used Spark in Databricks as Databricks jobs and used the serverless cluster the Databricks offers. For Polars and DuckDB, we built a Docker container that we deployed with Azure Container Instances. Because we ran the test on various data sizes, we'll say that in a moment, we actually increased the nodes until the job can run. So we got various sizes of nodes. So the benchmark, if we run it fully, it builds all those tables, right? We didn't want to run the whole benchmark, so we picked just 5 of them, 1 fact table, 3 dimension tables, and 2 reference tables. And in order to build them, we created this pipeline. It consists from 6 tasks. And a disclaimer here, we didn't run any kind of optimization in any of those tasks, in any of those tools, right? We just a simple run to see what happens. So let's dive into what each step actually does. First, we got the stage finwire, which has multiple CSV files as input. The main processing here is filtering, does some data type conversion and some column transformations. And the output, this task updates 3 different tables. On the stage industry task, we got a single CSV file. We just do a data type conversion, and the output updates just a single table. And we got the DIM company, DIM security, and stage financial. All those tasks do pretty much the same kind of transformations. They got 2 delta tables as input. They implement some joins and some column transformations and update a single table, each one of them. And finally, we got the fact daily market. Here we got 3 CSV files as input and 1 delta table. The processing are unions, joins, column transformations, and some filtering. And the final output is to update a single table. We will focus on the fact daily market because it's the most heavy task from all of them in our benchmark. So we got our pipeline. So let's see our input data sets. So the benchmark comes with a data generation tool. We can provide it with a scaling factor, so it generates various sizes of data. We used 4 scaling factors, and we see on the column of the total data size, the total size of the input data for the whole benchmark, right? It ranges from 1 gigabyte up to 50 gigabyte for the scaling factors we used. But as we said, we didn't run the whole benchmark. So what's important to keep from here is that our biggest table we built, it actually got 5 million rows on the smallest scaling factor, and the biggest scaling factor has more than 270 million rows. And it is fed from files that ranging from 0.3 gigabyte of data and up to 15 gigabyte of data. So the idea here is that those numbers are just an increment, right? So if you are producing, for example, in a day data, are those bigger than 15 gigabyte? Are they 30 gigabyte a day? If they do, so you can break them into 2 pieces. So you can do the incremental load of 15 gigabytes twice, right? In most cases, we can break down your data set into smaller pieces. So what are the performance metrics we got? We got throughput, which is very usual in our industry. It's actually the amount of gigabytes of data we can process during a minute. And on that duration, it includes the deployment of the node or the cluster accordingly, and the actual transformation process. Because this duration is what we charge for. And the second metric is the gigabyte per dollar. So it's the amount of gigabytes we can process for every dollar we spend. So let's see the results in a more readable form. So here is the throughput. What we see here is that for scaling factors of 10 and 50, which represent 0.3 gigabytes and 1.5 gigabytes of data, there is no important difference between those tools. But from scaling factor 100 and scaling factor 500, we see that Polars is more performant on those amounts of data, which is actually 3 gigabyte and 15 gigabyte accordingly. So let's see the results on the cost. The picture here is very different. Before we got only Polars to be an outlier. Here we see that Polars and DuckDB are way more financially performant than Spark. Again, I say for the data sizes we are talking about, right? So based on our experience, most, like 50% of data sets we process on the data transformation step are actually scaling factor 10 or scaling factor 50 data sets, which actually what we see here is that it makes absolutely no sense financially to process them with Spark. And we see that Polars is actually the best option in all of the scaling factors we tested. So my last 2 cents on this. Of course, there is no silver bullet, right? Each framework has its pros and cons. For example, Spark on Databricks comes with a lot of features to support the team and stay organized. That if you do something custom, like with Polars or DuckDB, you got to implement those things on your own. So for sure, if you choose something different, you add complexity to your system and your team. And so that's the reason why the tool choice should match the project maturity and the requirements. Okay. But what I see is that a multi-engine setup is what makes more sense overall. And of course, lastly, we don't need to go for the optimizations too early, because we are talking about data because we want, again, I say it again, to support our business decisions. So first, we need to validate the business value of the pipelines of our data. And if we are sure about that, and we have built some stable pipelines with predictable data loads, then we can go for some sort of optimizations, right? So what's our next steps? We want to explore the optimizations those choices offer us. All of them have major optimizations to offer, and push the benchmark a little bit further to see more transformation cases and see a bigger range of data. And if you are interested in that, you can scan for our repo. And that's pretty much it. Thank you very much for your time.
Thank you very much. So, do you have any questions for
Thank you very much for the presentation. Really, really interesting. Probably you mentioned it, but I didn't understand. How did you end up with a gigabyte per dollar metric for polars and for polars actually and ActiB?
For all them is actually the same. It's how much time it take to deploy the nodes and do the processing and kill the node.
The same infrastructure, you mean?
For polars and ActiB, yes. It's the same infrastructure. And for Spark, it's not the same, but it's pretty much similar because it's all of them serverless, right? So we got the duration, we got the size of the nodes and the cluster accordingly, and we know what the charging is for those clusters. So we run the numbers, and we know for each run how the amount of data we processed. So we run the numbers.
Yeah, this is kind of the same problem that I'm actually working on right now. Like my team has actually settled for DLT Hub for loading, and then DuckDB. How do you make sure that we are actually measuring the same system, the same thing in the benchmarks? Is this something that I will be able to see in the repository? Like, I mean, is it just the transformation step of data that you have already loaded as an input to the three different systems?
Yeah, okay. It's actually the same data. I implemented in the repo, you will find the transformation on its code base. We implemented the exact same transformations with all the different tools. So the experience is that we got the same data set, the same logic in code, and we have a serverless setup to have a clear charging. So we run the same task with different tools, and we got the
this is awesome. Also, thank you for the TPC D1 or I. Like, I mean, I will also check it out and probably use it myself as well for benchmarking.
Yeah, you can reach me out because
I will. For sure.
I had a hard time to make it work, to be honest.
Thank you.
Okay. Any further questions? No? Okay. Thank you very much, Christo.
Thank you very much.
And now we have a 5-minute break. Okay, everyone. So up next, we have Sam, and he will talk to us about pull request reviews. So Sam, the floor is yours.
Thank you. Okay. Hi, everyone. Thank you for coming to my talk. My name is Samuel, and I'm a senior software engineer at Bloomberg. I work on IB, which is Bloomberg's messaging application. I'm a full-stack developer, and we code primarily in Python and JavaScript. The title of my talk, if you came to a Python conference, now go to a PR review. I came up with this because I've been to a lot of Python conferences, and I feel like depending on the talk you go to, you might go to talks where you have to do a lot of research after the talk to be able to implement stuff, but I wanted to think about something actionable where if you're here right now, either you or your company, someone has invested a lot of money in you to be here, so I wanted to make sure that I gave a talk where you could kind of listen, not have to do a lot of research on your own, and be able to implement things when you go back to your regular job, and that's what I hope to do with this talk. I focused on PR reviews because I feel like PR reviews are an often overlooked way to make an impact. I think if you're an engineer, you think that you can make an impact by writing a lot of code, doing a lot of design and technical work, but I think PR reviews is a really good way to make a big impact as an engineer. I'm going to go over kind of why I think that's the case. So really quickly, the agenda for the talk, we're going to have a brief introduction. We're going to talk about the archetypes of bad code reviewers. We're going to talk about the technical knowledge that I feel like you should have to do PR reviews in Python effectively. We're going to talk a little bit about communication related to PRs, and then we're going to just end it with a conclusion and a takeaway. So really quickly, why am I focusing on PR reviews? So PR reviews boost code quality and team learning. It's a really good way for you to be able to show other people on your team what you know. One way to do that is by doing PR reviews properly. The other thing is if you're a good senior engineer, you can catch bugs early before they go on to production. A lot of times code that gets merged really quickly without having gone through a good PR cycle can end up crashing on production. And if you're a good solid senior, you want to be able to catch that before that happens. It's a good way to do mentorship and collaboration, just teamwork. You can't always code with someone, but you can review their code when they're done doing it. It's critical for scaling projects. Like I kind of said before, you can only write so much code as an individual contributor yourself, but if you write code and then you review code for other people, it's just more of an opportunity for you to make an impact at your company. And then, yeah, it scales the contribution that you can make as an individual. So what's unique about Python PR reviews? Why is it different than doing PR reviews in any other language? There's a lot of similarities with the teamwork and collaboration, but there's a lot of things unique to Python that present a unique opportunity to do PR reviews in Python. One is that Python is dynamically typed, which means that you need to increase the context that you have when you're doing these PR reviews, which means you also need to scrutinize deeper. If you have a typed language, you can kind of infer the data that's being passed around, but if you're doing PR reviews in Python, you need to be more mindful of that. Python is idiomatic. I think as engineers, we often think about there's many ways to solve a problem, but with Python, it's unique in that there are still many ways to solve a problem, but there are a couple of Python-specific ways to solve problems, and we'll get into that a bit. And then Python has batteries included. I think engineers often go into the habit of making new solutions for things that already exist, but Python has a lot of libraries and a lot of things in its package that you can use that a lot of people just aren't aware about, so we're going to go into a couple of that as well. So what did I mean when I said Python is idiomatic? So on the left, you can see the less Pythonic index loop, and on the right, you can see more Pythonic using enumerate. They're kind of the same lines of code, but one benefit of writing Python that's idiomatic is that if you have a large code base and you don't do idiomatic Python, let's say you solve a bunch of different problems different ways, that leads to your code base solving the similar problems in very different ways, which makes it hard to maintain. It makes it hard for a new developer to come and understand, but if you solve similar problems in similar ways, it makes it a lot easier for you to be able to understand your code and for newer people to come and be able to contribute quicker. Python has batteries included. So there's the with statement for resource management, there's default dict, there's pathlib, there's a bunch of other things in the Python library that you can use that will help it to be more idiomatic but also be shorter. And then those are that's kind of a super high level, but if we go into part one of this, which is the archetypes of bad code reviewers, I wanted to talk about like some of the code reviewers I've experienced, and I think the negative things about PR reviews that tend to be common, and I kind of bucketed them into three different groups I'll go over right now. The three different groups are the looks good to me reviewer, the technical nitpicker, and the nit commenter. So the looks good to me reviewer, they kind of leave vague and unhelpful comments. They don't really engage with the code. They can miss bugs, and then they can miss things that the person making the PR is doing, and then they don't really offer you any direct feedback. I think a lot of times I even get put into a situation where I review someone's code, and it more or less it looks correct to me. There's really nothing I can leave a comment on. If I do leave a comment, it might just be nitpicking, which is one of the other archetypes I'll talk about. But I think even if that's the case, if you're reviewing someone's code and there's nothing wrong with it, I think it's a good idea to say, hey, this is what I reviewed, this is what I think your design is, this is why it looks good to me, and then approve it. So even if there's nothing wrong, I think it's still helpful to kind of say what you reviewed so that the person who's making the PR, they might not know that they wrote flawless code and you don't have any issues with it. They might be leaving unclear about what was actually reviewed. So if you kind of, even if it looks great, even if you just say, this is what I reviewed, this is what I think your code is doing, that's still helpful. The other one is the technical nitpicker. They focus on minor or irrelevant issues like variable naming or like personal styling preferences. They kind of overwhelm the PR with a lot of small but low impact comments. They create work for you to do as, like if you're someone making the PR, you have a bunch of comments and there's a lot of work you need to do now to make all these updates, but it's kind of unclear why making these updates are gonna help and why it's gonna make your code better. And it kind of discourages contribution because if someone is leaving a lot of, let's say you make a PR and you've got like 20 little nit comments, it kind of stops you from being able to engage with the person or engage with your code more. And you kind of just end up having to solve all these small problems. You don't really know why you're doing it. And you definitely don't want to be this person. I think the solution here is that you want to make sure that you weight the comments that you give by the impact that they have. If you feel like you have a lot of small comments, but they're not going to make a lot of impact, I would refrain from doing that. But if you feel like you have a lot of comments that can make a lot of impact, kind of leave smaller but more impactful comments and stay away from leaving many less like nitpick comments. And then the third one is the nit commenter. So this is different than the second one where this person does find bugs and they find things that you probably are doing wrong, but they don't really explain it to you. I think this is probably the most common one where if you're a junior and you're giving a PR to a senior to review, or if you're a senior and you're reviewing it, it might be really clear to you why something is wrong and you might not understand, or you might just think if you just leave a small comment, they'll be able to figure it out. But I think with PR reviews, you want to use that as an opportunity to communicate and show that you can communicate and show that you can teach. So I think for the solution to this, if I had to give one solution, it's really simple. Just explain why you're saying to do something. So if you think something is inefficient, maybe explain why that's inefficient, and then go into detail about what is a more efficient way of solving the problem that they're trying to solve. But these are kind of the three archetypes of bad code reviewers that I have seen. So if we move on, how do you actually like give feedback? How do you make sure that you're not one of those three people? The first thing is you need to make sure you kind of have like a baseline level of Python knowledge that I have seen by doing PR reviews about the mistakes that people make and how you can kind of make sure that the PR reviews that you do are effective. So if we go into that kind of one by one, the first thing is knowing about Python's model. Python is not passed by reference, it's not passed by value, but it's passed by Python variables reference objects. So what does that mean? Before that, we need to discuss whether or not something is immutable or mutable. So when reviewing Python code, you need to ask yourself, will the object be mutated, and is this mutation intentional? So to keep in mind, the things that are not mutable are int, strings, and tuples. The things that are mutable, meaning they can change in your functions, are list, dicts, and sets. So if we show an example right here, you can see that I have an add one function that takes in a list of numbers and adds one to each thing. This function is clearly mutating the list that is passed in. But if you're reviewing code, you kind of don't know if this mutation is intentional or not. You have to like ask the person making the PR. You have to look at other context. You need to figure it out. But you won't even know to do that if you don't know about Python's object model. So another thing is default mutable args. On the left, you can see that we have an append method that has a default list being passed in where it's an empty list. On the right, we have the same append method, but it's taking in none instead of the default one. And if I go on to the next slide, you want to be using the one on the right and not the one on the left. The one on the left is maintaining state because, again, lists, like we said, are mutable. So since they can change if you pass them around in functions, if you call append once and you pass something in, when you call it with another number, it'll keep that state. But on the right, where you pass in none instead of an empty list, you're not getting that state management issue. And again, I'm not saying, in this image, I'm clearly saying one is bad and one is good, but I think the more important takeaway is that you want to make sure you understand why someone is using an empty list or why someone is using none. But if you don't know the distinction, then you're not able to make that comment in a PR, so that's one thing to keep in mind. Default mutable args, there's a lot of potential bugs that can come with it. So there's shared state across function calls. The default list is created once, so subsequent calls modify that same list. There's non-obvious behavior in loops and tests. It's especially harmful if you're doing test code or APIs where the user assumes that there's some fresh state. If you're passing in the same list, then that won't happen. And it's also hard to track side effects. Reviewers might not notice state being preserved unintentionally, so you just need to be really mindful of that. And again, so if you're dealing with default mutable args in code that you're reviewing, you just need to check whether or not they're using lists, dicts, or sets. And if you see something, you just need to ask yourself, should this be a fresh variable every time, or should this be not fresh? And then many Python developers, even experienced ones, don't know how to look at this effectively, so this is something that I wanted to call out. Now if we move on to efficient and idiomatic Python, this is where a lot of opportunities come in as well. So Python offers elegant and concise idioms that reviewers should encourage. This basically means don't solve problems that were already solved for you. Kind of do things the Pythonic way so that if someone is looking at the code later on, it follows kind of a similar pattern. One example of that is loops versus list comprehensions. So on the left, we have a verbose loop, and on the right, we have a less verbose list comprehension. This is kind of a very simple example, but you could already see that the code on the right is much shorter. And shorter code is fewer lines, and fewer lines means there's less context for you to maintain, less bugs that can go into production. The one on the right expresses intent more clearly. It's very clear what you're trying to do. And it's also often faster because different compilers optimize bytecode differently. So if you have the code on the right, it'll often run faster in production environments as well. There's also map and filter versus comprehension. So on the left, we have a filter. On the right, we have a comprehension. It's easier to read for more Python developers. It avoids the anonymous Lambda function we have on the left. And again, it's just more Pythonic and more idiomatic. And then we're going to go into generator for a little bit. So generators provide lazy evaluation. They're memory efficient for large data sets. They're composable built-in tools like iter-tools. And they're great use cases for streaming data like APIs and logs. So you can see on the left, we have a list comprehension. On the right, we have a generator. Again, this is just one line of code, so it doesn't really change the complexity too much. But it's more Pythonic and modern code bases, which means that over time, if you're managing a really large code base, if you're using generators, it just makes it easier for people that are interacting with your code base to understand it eventually. So for generators, there's kind of a few things you need to ask yourself when you're reviewing code. Could this for loop be replaced by a generator? And then do you have a list or another large collection? And could a generator help you save memory with that? And ultimately, you just want to ask yourself, is there a more expressive way to do the thing that I'm trying to do? And often you'll see that generators help you do that. And then the next thing that we'll move on to is underutilized tools in the Python standard library. Like I said in the beginning, Python comes with batteries included, but many devs don't use them. And as a reviewer, you want to spot manual code that could be replaced with standard tools that make for high impact in your code, but also make high impact comments for you as a reviewer. And you want to emphasize that Python provides a lot of elegant built-in ways to solve common problems. So one example of that is using pathlib over ospath. On the left, we're using ospath, but on the right, we're using pathlib. It's cleaner syntax with the / operator. Pathlib also has more powerful methods like retext, exist, and glob, and it's better for cross-platform safety as well. With ospath, it might not work the same way on different platforms, but with pathlib, it's abstracting away a lot of the low-level OS stuff for you, so you just don't need to worry about that. Another thing that you can use is default dict that most people don't use in code. On the left, you can see that so many of you have an empty dictionary, and they need to do a check every time to see whether or not something is in that dict. But on the right, they're using default dict, which kind of takes away that little bit of boilerplate they're using because they're using a real dict. So in this example, using a default dict, it removes boilerplate, it encourages safer, shorter logic, and it can also be used for grouping. Like you can do default dict, and you could pass in a list. So if you're reviewing code and you see someone is using if key not in dict, that's often a good indicator that they can use a default dict to solve that problem. Another thing that's really helpful is type annotations. On the right, you can see that we're using type annotations to show what type this function gets in and what it also outputs. This just makes code easier to understand and maintain. It enables static analysis like MyPy and PyWrite. It encourages clean APIs and phase refactoring. This is something that I really like using, and I found that most people don't use. But again, if you're doing a PR review, you want to make sure that you leave high-impact comments, but not high-impact comments just for the sake of like leaving comments, but you want to make the code base ultimately better to maintain and use long-term. And type annotations in Python are not used that regularly, but they help a lot. Another thing is using data class. Just like with default dict, it removes a lot of boilerplate. If you're using data class, you might think you can just make a class, but if you make a class, you have to put in a lot of boilerplate, like you have to do an init method, a wrapper method, and a bunch of other stuff. But if you're using a data class, let's say you have a class that shouldn't have any methods, it's just an object that's going to hold data, you can use a data class for that, and that provides kind of a much cleaner way for you to be able to just have an object that should only contain data. And to the reader or to other people that eventually would interact with your code base, it'll signal that this class is meant to hold data and not manage behavior. So that was kind of the extent of the technical thing that I want to go into, and now we'll kind of finish it off with the communication related to all of that knowledge. When you're doing code reviews, you want to kind of keep 4 simple principles in mind. It's clarity, respect, specificity, and then you want to explain why. So if we go into the first one, clarity, you want to say what you mean, you want to be concrete. I think if you're doing a PR review, a lot of people might fall into the thing where, oh, if I just say this one quick sentence, they'll know what I mean. But especially if they're a new developer, or even if they're a senior developer, they might be working on multiple projects, multiple PRs at the same time, across multiple languages. It might not always be clear what you mean. So I think if you just say what you mean really simply, really concretely, it makes it easier to take PR review feedback. The other thing is respect. I think rarely, but in some occasions, I have definitely seen where people kind of assume bad intentions when they look at a PR. But what I like to do myself is when I'm doing a PR review, I kind of always assume good intentions. I assume that someone wanted to do things the right way. And if they didn't do it the right way, they either didn't know or there's some other thing that came up. So I kind of always try to be respectful. And you always want to make sure you critique the code, not the person. PR reviews can end up being kind of a little heated and personable if they get into that. But if you just focus on the code and the technical things that you're reviewing, less so on the person that you're reviewing, that makes that process a lot smoother. And then the third one is specificity. You want to point to specific lines in code. You don't just want to say, this PR looks bad or this PR looks good. If something looks bad, you can point to a specific line and say, hey, I think this looks bad for reasons ABC. Or if something looks good, you can say, I think this looks good for reason ABC. But you want to make sure that you're specific on why something is good or bad. And then you want to actually describe the issue. You don't just want to call something out and say, this is bad. You can be like, this is inefficient because this loop is doing this, but it should be doing this. And that's kind of what I mean by be specific. And the last one is explain why. This is kind of baked into all of the other stuff that I've talking about. But you don't want to just say what to change, but you want to say why the change that you're suggesting is an improvement. Because if someone doesn't really know why something is better than whatever they were doing, it kind of makes them less reluctant to do so. I definitely feel that way. I feel like when I get feedback comments, it's important for me to learn why something that someone is suggesting is better or why something is different, like a better way, and you want to make sure you convey that and explain why. So takeaway for Python PR reviews, Python is expressive. There's Pythonic code versus working code. I think engineers often fall into the problem of there are many ways to solve this, so kind of anything can work. But with Python, especially for really large code bases, you want to solve the same problems the same way. That makes it a lot easier for people to maintain long term, and you want to do it in a Pythonic way. You want to balance correctness with timeliness. You want to make sure you don't overwhelm a PR with a bunch of small nitpick comments. You want to make sure that you leave kind of high impact comments, so you want to focus on the most important things. And then if you're a senior and you're doing a lot of PR reviews, you want to use your experience to mentor and scale your impact. There's only so much code you can write as an IC yourself, but if you're reviewing other people's code, that's kind of a part of the work that you did that goes out into production, and ultimately that's just what you want. And that is it. Thank you.
Thank you very much, Sam. So, do we have any questions for Sam? Question?
Thanks a lot for your talk. Well, my question it's about junior developers, and On most cases, for seniors, it's clear how to do a proper pull request, but code review. But what happens with juniors? How can they contribute? Because we want them to be engaged and we want them to check PRs themselves. What are the things that they can find when reviewing more experienced developers?
Yeah, I think they should just kind of ask questions. At least that's what I did when I was really new. When I was new, I kind of had this conversation with my manager, and I was like, I don't know what help I would be leaving by doing a PR review because I don't really have that much knowledge. But I think when you're a junior, people are often more willing to help you, and they're more willing to explain things to you. I think once you spend more time in a company, even if you haven't acquired maybe that much knowledge, I think the more time you spend somewhere, the less people want to help you. And we can argue whether or not that's good or bad, but that's kind of just realistically how it goes. So while you're new, you want to use that time to ask a lot of questions. And then hopefully after like, I don't know, 6 months, a year, however many PR reviews you end up looking at, you'll get better understanding of the code base more. And I think at the very least, you'll understand how your team does something. So even if you might not have a lot of like deep technical knowledge, you'll know enough to know how something should look, and you'll be able to leave some kind of meaningful feedback.
Anyone else? Okay.
So this is not entirely related to human reviews. I wanted to ask if you've used any AI tools for PR reviews, and what's your opinion on them?
I've not used any AI tool for PR reviews. I mean, I've used AI tools to ask it whether or not something could be more optimal or something could be like changed, but I've never used it explicitly for PR reviews.
Okay, thanks.
Okay. Anyone else? No? Okay. Thank you again, Sam, very much.
Thank you, everyone.
Okay, everyone, welcome back. So next up, we have Ashta, and she will be talking to us about async I/O.
Thank you. Hello, everyone. I'm Astha. I am a software engineer at Bloomberg, and today I'm going to be presenting on the topic why your async code might be slower and how to fix it. So a little bit about me. I did my bachelor's in computer science and applied mathematics from IIIT Delhi, and then I moved to London and joined Bloomberg. So I work with the research integration team in London on the document search platform. I'm really excited to be here today. So let's start. So let's look at a problem that many developers face when they get started with async I/O. So you have some code, you wrap it in async I/O, and now you realize that it's actually slower than the non-async version. So what went wrong? So the agenda for today's talk is going to be, we're going to look at the core concepts of async I/O. So this is going to be a beginner-friendly talk, and I'm not assuming that you have any knowledge of async I/O. We're going to look at the common mistakes that developers make while using async I/O. Then we're going to look at their fixes and best practices while using async I/O. And we are going to look at something that's very important, which is debugging your async code. And finally, choosing the right concurrency model for your workload, whether to choose async I/O, threads, or processes. So what is async I/O? So as the Python documentation says, async I/O is a library to write concurrent code using async await syntax. And it is used as a foundation for multiple asynchronous Python frameworks. And it is often a perfect fit for I/O-bound tasks and high-level structured network code. So let's start with the core concepts of async I/O. So the first is the event loop, which is the core of every async I/O application. And in Python, you can start an event loop using async io.run. And it manages and schedules the execution of asynchronous tasks and callbacks. And it runs in a single thread and handles tasks cooperatively. Then we have coroutines, which are asynchronous functions declared with async def syntax. So as you can see on the slide, there's an example of a fetch data coroutine that calls awaits on async io.sleep, so it can be paused and resumed using await. Then we have tasks that wrap coroutines and run them concurrently. So here we have an example of a coroutine nested, and then we wrap it using async io.create task to create a task, and this can simply be awaited until it's complete. So tasks are scheduled on the event loop. Then we have futures, which represent the eventual result of an asynchronous operation. And you'll not typically encounter futures unless you are working with a library or some async I/O APIs. So it's a low-level awaitable object. Now we looked at some of the core concepts. We're going to look at a piece of code which we are going to convert from synchronous to asynchronous. So on the left, we have a synchronous piece of code which has a fetch data function, and it calls time.sleep and waits for 2 seconds. And then we are calling this fetch data function in the main. Now we convert this piece of code to be asynchronous using async I/O. So we convert this fetch data into a coroutine using async def. And we also replace time.sleep with async io.sleep, which is the asynchronous version. And then finally, we await this fetch data in the main. And we start an event loop using async io.run. So we looked at some of the basics of async I/O and how to convert your synchronous code to asynchronous. But just simply using async await doesn't make your code run concurrently. So we're going to look at some of the mistakes that you might be making while using async I/O. So the first mistake is sequential execution instead of parallel execution. So you use async await, and you just assume that the code would run concurrently. But that's not the case. So as you can see in this example on the slide, we have a fetch user summary function where we get the user notifications, we get the recent activity, and we get the unread messages. And then we finally return from this function. And we would assume that since we are now using async I/O, it would run in parallel, but that's not the case. So we are waiting for each task to complete for the next one to start. So all these calls are still sequential and not parallel. Now to convert this to parallel, you can use async io.gather, and this would reduce the execution time a lot. And now this piece of code is going to take the max of these 3 tasks to complete. And now finally we return all of these, and it reduces the execution time. And one thing to note here is that the example we just looked at, so all the tasks in this case were independent and didn't rely on each other. So if you have a piece of code where one task relies on another, then it must be executed sequentially and not in parallel. So now we're going to look at a piece of code where we compare the execution time of sequential and parallel execution. So in line number 16, you can see we have a sequential function which makes 2 sequential calls to fetch data. And then we have a parallel function which makes a call using async.io.gather. And now we benchmark the execution time of these 2 functions. So this is the output that we get. A starts and ends, and then B starts and ends for the sequential. And it takes a total of 2 seconds. Whereas when we are using async.io.gather, both the tasks start at the same time and they end at the same time, and it takes 1 second to run. So we looked at concurrency using async.io.gather. It runs your coroutines concurrently, which we just saw, and all tasks start together. But there's one thing to note with async.io.gather, which is silent failures. So it's not very great at error handling, and there's no per task control. So as you can see in this code example on the right, this code would raise a value error for n equal to 1, but this code is going to fail for n equal to 2 as well, as if any task which raises an exception, then gather will also raise an exception, and all of the coroutines which was n equal to, with the one with n equal to 2 in this case, will also get cancelled. So now a fix for this could be to use async.io.createTask. Now what createTask allows you to do is that you can handle errors per task, and you can run tasks in background as well. So in this code example, we are using createTask to create 2 separate tasks, and now if you want to handle errors separately for the tasks, you can do that. Now, createTask had one problem here, that we had to await all these tasks separately, and we have to manage all the tasks separately. Now, for a more structured concurrency management, you should go with async.io.taskgroup, which was introduced in Python 3.11, and it's a more modern alternative to createTask. So as you can see in the code example, it's an asynchronous context manager holding a group of tasks, and we can add tasks to this using the createTask function. And when this context manager exits, all tasks are awaited. Now here's a quick comparison I have prepared of gather versus createTask versus task group. So all 3 of them allow you to run your tasks concurrently, but gather does not allow for per task control and error handling. And for more structured concurrency management, you should go with task group, but it's not supported for versions less than Python 3.11. So if you're an older Python version, then I would suggest going with createTask. Or if you don't need a specific error handling, you could also use gather. Then the second mistake we're going to look at is using synchronous libraries in asynchronous code. So using libraries not designed for async code can block the event loop. For example, if you look at this piece of code, we have a fetch data coroutine, and it uses the request library to fetch a URL. And then finally, we're using async.io.gather to make 2 fetch data calls. Now, since we're using gather, we would just assume that this code runs in parallel, but that's not the case. Since this request library does not support async.io, it's going to be blocking, and these calls are still going to be sequential. Now, a fix for this is to replace this request library with an asynchronous alternative, which in this case could be maybe IO, HTTP, or any other similar library to fetch requests. So this is the fixed piece of code where now we're using IO HTTP, and this code is now going to run in parallel and lead to a reduction in the execution time. So here are some more libraries and their asynchronous alternatives. So initially when we were converting the synchronous piece of code to asynchronous, we saw that we replaced time.sleep with async.io.sleep. Then we also have pathlib, which can be replaced with IO files. And you could also think of contributing a feature to a library if it does not support asynchronous versions for that. The next mistake we're going to look at is blocking the event loop with CPU-bound operations. So as you can see in this diagram on the right, we have a CPU-bound task which takes 1 second to run. And then we have an IO operation which takes 2 seconds. So the response to the client is eventually going to be delayed by 1 second. So since async IO runs all coroutines in a single threaded event loop, executing the CPU-bound operation inside the coroutine can freeze the entire event loop, and it's going to delay the response to your client. So what you could do in this case is to offload the CPU-bound task to a separate process or thread. And in Python, you can do that with the loop.runAndExecutor method. So here's a code snippet that I've taken from the async IO documentation, where we have a blocking IO function, and then we have a blocking CPU-bound function. And then it basically just uses loop.runAndExecutor method and the thread pool executor to create default thread pools, custom thread pools, or custom process pools. So you could basically offload these to a separate thread or process, and then your code, it will not block your code anymore. So now we're going to look at a live demo of a piece of code. On line number 15, we have the blocking version, where we call the CPU-bound function, and then we await the fetch data. On line number 20, we have a non-blocking piece of code, where we get the running loop, and we start the task using createTask function, and then using loop.runAndExecutor method, we run the CPU-bound function in a separate thread. So we're going to look at the output of these two versions and see what the difference is. So here we have the blocking piece of code where the CPU-bound task starts, and then you saw that the execution stopped for a bit. And when it gets done, that's when we start fetching the URLs. So as you can see, it's basically pausing the execution. And now in the non-blocking version, the CPU-bound task starts, and we're also fetching the URLs at the same time. So you can see that it's not blocking the execution of the fetch data anymore. So another mistake that you could be making is blocking the event loop with non-critical tasks. One of the examples for this could be sending logs to a service. For example, in the slide, we have a code example where you're sending logs to an external service, and then we get returned to the user profile. So sending the logs is blocking the response to the client, and since the logs could be sent in the background, it's non-critical and it delays the response. So here we have a non-blocking piece of code. Now where we're using async io.createTask to send the logs in background, and this does not delay the response to the client. So you could use async io.createTask or also the loop.runAndExecutor method, which we saw before, to send the logs in the background and for other non-critical tasks as well. Now, another issue is creating too many tasks. So creating a large number of coroutines, especially for trivial operations, can flood the event loop. And it can also introduce a significant overhead due to context switching, and it can potentially slow down your application. For example, we have this piece of code where we are performing a trivial operation, and it's a large number of coroutines being called. So what you could do in this case is that you could batch your coroutines, and then this would reduce the scheduling overhead. And another thing you could do is you could use a counting semaphore. So this is an example of using a semaphore where we basically limit the maximum number of concurrent operations allowed. And then we can basically work with this semaphore using an asynchronous context manager. So the example in this case would limit the number of resources to 10. The next issue, which is very common, is never awaited coroutines. And this results in the function never being called and never being scheduled in the event loop. So your code might look fine, but it fails silently. So one way to catch these kind of errors is to use linters in your code. So this is an example where now, so you can use flake8 async or pylon to catch these issues. Or you could also run these tasks in the background using async io.createTask function. Another issue is improper resource management. So since async code often interacts with external resources like files or database connections, improper cleanup of these can lead to resource leaks. So one fix for this is to use asynchronous context managers, like async with in this case. So in this example, we're basically opening a file. So the asynchronous context manager here ensures that the file is closed properly and all tasks are cancelled and awaited properly before the shutdown. Now we looked at a lot of mistakes that developers make while using async I/O. But how to catch these mistakes? So now we're going to look at how to debug your async code. And there are several ways to enable the debug mode in async I/O in Python. One of the ways could be exporting an environment variable. Another way is using the Python dev mode, which automatically enables the debug mode for you. Or passing debug equals to true when you are creating an instance of the event loop. Or setting the set debug on the loop if you have an instance of the loop. So these are the kind of errors that debug mode helps us catch. It helps you catch non-awaited coroutines. So if it would return an error that coroutine test was never awaited. And many non-thread safe async I/O APIs raise an exception if they are called from a wrong thread. So you will see an error like runtime error, non-thread safe operation being invoked. Then the callbacks, which are taking longer than 100 milliseconds, are logged. So this is very useful if some piece of code is taking very long to run. And you can also set this time, if you want to update it to something lower or higher, you can do that. Then the execution time of I/O selector is also logged if it takes too long to perform an I/O operation. For example, in this piece of code, you can see that we call time.sleep for 1.5 seconds, which is going to block the execution. So it logs the execution time, and that can help us catch this type of errors. So now we're going to look at a piece of code which has issues, and we're going to use the async I/O debug mode to help us catch these issues. So here on line number 15, we can see that we have an unawaited coroutine, and on 16, we have a slow task. So we're going to use async I/O debug mode and see what kind of errors we get. So we enable the debug mode using debug equals to true in line number 18. And then we are also setting the logging to see async I/O debug messages. So this is the output that we get when we run this code. Highlighted in yellow are the errors. So you see we get a runtime warning that the coroutine was never awaited. And it also logs the execution time that it took 1.509 seconds. So we looked at the debug mode in async I/O, but what are some of the other tools that you could use for debugging your async code? So there is Scalene, which is a high-performance CPU and memory profiler for Python. So looking at how much time your program is spending in CPU versus memory, you can see what are the issues with your code. And also this has 10K stars on GitHub, so that's why you should use it as well, and it's actively developing. Next, we have I/O Monitor, which is a module that adds monitor and CLI capabilities for async I/O application. We have PDP, the Python debugger, and you can use PDP using import PDP and use pdp.setTrace to then set up breakpoints, and that allows you to interactively step through your application. And we have PyStack that prints the stack trace of a running Python process or of a Python code dump. And then looking at the stack trace, you can find out what program is still running or what are the issues with your code. So these are some of the tools that you could explore further. Then choosing between the right concurrency model, whether to go with async I/O, threads, or processes, is crucial for performance and efficiency. So here's a quick guide on when to use what. So use async I/O for high-volume tasks that spend time waiting, such as handling network requests or reading files. Threads for I/O-bound tasks that may also need shared data access. And since threads run in parallel within one program, they're suitable for light processing with some waiting. And processes are perfect for computation-heavy workloads, with each process runs independently using multiple CPU cores for true parallelism and making them great for maximizing performance on intensive tasks. So as you can see in this image, in the threads, we have the shared code, data, and files, and we have independent register and stack. And for processes, we have independent code, data, and files, so it makes them good for true parallelism. So here's a quick summary that I've prepared for comparing these three concurrency models. So use async I/O for efficiently handling many concurrent I/O tasks, threads for parallel I/O tasks with shared memory, and processes for maximizing performance on CPU-intensive tasks. So the key takeaways from today's talk were batch your coroutines using asyncio.gather or asyncio.taskgroup. Avoid mixing synchronous and asynchronous code. Keep your async workflows separate and avoid wrapping synchronous code in async await. Execute blocking code in thread or process pools using executors like loop.runInExecutor method that we saw today. And if dealing with large number of parallel requests, use asyncio.semaphore or similar libraries to throttle concurrent tasks. And use tools for debugging. For example, you could use the asyncio debug mode that we saw today, or the many other tools that we saw. Thank you. Feel free to ask any questions.
Thank you very much. So any questions? No?
Hi, thanks for the talk. My question is about debug mode. Do you have it enabled constantly in your development environment, or is it something that you would enable in case you need to debug something?
Yeah, so it's not enabled by default, so you need to go and enable debug mode. And like these are the different, like we looked at the different ways. I'll just skip to that slide.
I'm asking, what is your preference? Like in your local environment, do you have it enabled?
I don't have it enabled by default, so I go and enable it if I need to debug something. Okay. But that's a personal preference.
Okay. Anyone else? No?
Hi, I hope you can see me.
Yeah.
So I'm not really a Python developer, and I very recently had the task to profile a big Python code base that does a lot of async stuff. And my experience with a lot of what I understand is standard tooling was really subpar. So I was wondering maybe if you can say a few words about what Scalene is and how it can be used exactly.
I haven't used profiling personally, but I was reading up an interesting blog which was like comparing the time it spends in CPU versus memory, and then like mentioning what all issues you could find there. So I haven't used it personally as well.
Okay. We do have some more time for any other question. No? Okay. So thank you again very much.
Thank you.
So next up, we have a 20-minute coffee break, and we're at the sponsor area. And Elastic will announce the winners at the Kahoot quiz at their booth, also in the sponsor area.
Everyone, hope you feel rejuvenated after the coffee break. Next up, we have Michael Lukeris, who's going to talk to us about deploying smart agents with LangChain. Please give a warm welcome to Michalis.
Thank you. Thank you. Thank you. Okay. Hello, everybody, and welcome to my session about smart agents with LangChain. I'm Michael Lukeris. I'm a research associate at the University of Athens in the PICOB lab. I'm also a member of Django Software Foundation, a volunteer at PyCon Greece. That's why I'm wearing the yellow t-shirt. And I volunteered in a couple of Django conferences across Europe as well. By the way, in case you missed it yesterday at the lighting talks, it was announced that the next DjangoCon Europe will be held in Athens. Yeah, amazing news. Yeah. I hope I see all of you again next year. I love programming in Python and in Django. I've been coding for over 10 years now. I use Python for building web applications, data analysis apps, and artificial intelligence projects. If you want to connect with me, you can scan the QR code, and this is my X account and my GitHub account. I promise I rarely post on X, but when I do it's about funny things, about Python and programming in general, I come across in books, articles, and blogs. So now, without any further ado, let's dive into the presentation. Just a quick disclaimer. This is my first PyCon talk in the very first Python conference in Greece. So please be patient with me. And as you may have guessed from the title and maybe the summary of the presentation is about building and deploying smart agents with LangChain. Or is it? I'm so sorry, no, okay. You know, things move fast, especially in the Gen AI domain. So when I first wrote the talk proposal, LangGraph was just another option for building agents in the whole LangChain ecosystem. But now, and especially in version 1.0, the LangGraph is the recommended way to build agents, and all the agentic code in LangChain, the LangChain package is deprecated. LangGraph is a low-level orchestration framework for building, managing, and deploying stateful agents, as we will see later on. And in this presentation, I will mostly focus on LangGraph. We will also explore some of the LangChain components that are, okay, they are optional, but they perfectly align with LangGraph. Okay, the first and the only step in this journey is to choose your favorite large language model, maybe Gemini, Grok. If you don't have a favorite, it's perfectly fine. You can open all of them in parallel. They offer a free tier. As you can see, they have the same user interface, so the learning curve is almost flat. And you can go and ask questions. How can I build an agent? How I will deploy the agent? How to use LangGraph? And that's it. You don't need me anymore. I mean, that's the end of the presentation. Thank you. No, I'm kidding. Okay. It's not going to be that easy. And don't leave the room. It's not going to be that hard. I'm not going to dive into complex mathematical equations. It's just code, and that's it. That's it. I promise. Okay. Now, in order to set the scene for the presentation, and as I'm from Greece, and we are, I'm presenting at a Greek conference, okay, Greek people will understand, I need to start with a connection between agents and ancient times, ancient Greece. Yeah, I must start with a connection, with a relationship. And you know what? It wasn't that difficult because there is a connection. If you didn't already know, back in ancient times there was Pythia. Okay, Pythia was the high priestess of the temple of Apollo at Delphi. Delphi is a city which is like 200 kilometers away from Athens. I totally recommend to visit now or maybe the next time you come to Greece. And it was something like a smart agent. So important people like kings and philosophers. Yeah, if you don't believe philosophers were great people and important people back in ancient times, they would travel there. They will prompt the system with their questions, and they wait for an answer. There was a specific protocol. There was an API. There was rate limitation, just one prophecy per moon cycle, and no refunds. Okay. And the funniest thing is that the same problems that we face with today's large language models and smart agents are pretty much the same that people faced in ancient Greece. Yeah, it's hallucination, confusion, bias, ambiguity, with the output, the result of the smart agents. And yeah, there is a popular story. This story is about Croesus. Croesus was the king of Lydia back then. He obviously didn't know anything about large language models, smart agents, or artificial intelligence in general. But before going to war against Persia, he visited Pythia and gave a prompt. The prompt was something like, should I go to war against Persia? If I attack, what is going to be the outcome? And the answer was the classic oracle style, if you cross a river, a great empire will fall. Okay. And can you guess the result? Yeah, if you don't know the end of the story, he attacked, and it turned out that the great empire that fell was his own. So his empire, his army crossed the river and fell. And that's the end of the story, yeah. By the way, this is what we call zero-shot prompting. I think most of you have, during vibe coding, you do zero-shot prompting. It's when you give the question to the system without any context, without instructions, without examples, and hope for a good answer. Yeah, an example is build me a website. So, what if Croesus knew about prompt engineering and smart agents? Then maybe his prompt would be something a bit different, let's say. Maybe there would be the prompt on the right side of the slide, but on the left side, we can see a whole bunch of text with instructions, with tools, with examples, with everything. And the thing is that Croesus' problem was probably solved, but not our problems, because now we have to face another problem. And yeah, let's be honest, okay, we are developers, we are introverts, we don't want to write documentation, we don't want to write plain text, we prefer to write code, variables, protocols, classes, objects, maybe tests, okay, maybe type annotations, maybe docstrings, but for sure, no long explanations. And this is where the LangChain ecosystem with LangChain and LangGraph comes to the rescue. It basically saves us by turning all the plain text we saw earlier into things we actually like to write, which is code. What is more is that it keeps everything abstracted so that you can use different implementations, different large language models, different vector stores, different RAGs, without changing the code, without changing the core of our code. And LangChain follows a modular and extensible architecture. Everything is organized in different packages. So there is the LangChain package, there is the LangChain core package with core functionality and core components, LangChain OpenAI for using OpenAI components like ChatGPT, like OpenAI embeddings, LangChain community for using community components, and you can actually download them independently. You can import the package, you can import the module, you can get the components, you can mix, you can match, you can customize, a kind of like playing with Lego. And now let's try to identify, in the previous example, some of the LangChain and LangGraph components. And let's start with the human message. The human message is actually the final prompt. This is an object of the human message class, which is part of the LangChain core package, and represents a message coming from the user. Then we have the system message. The system message represents sets the role and the behavior and the background of the AI model. The system message usually starts with something like, you are a helpful assistant, or you are an expert in this domain, you know what I'm talking about. Then we have a result of a retriever. I don't know if you managed to to see the previous presentation about RAG. So a retriever was used to get results from the knowledge base. So for the RAG example, we have a vector store, and where we save the embeddings, we can get a retriever with the top matches related to our question. Or a retriever can be a retriever from an SQL database or from a non-SQL database, which searches and returns the most relevant rows or documents based on the question. Then we have a bunch of tools that are available. Then we have the long-term memory. Long-term memory is used to store user-specific stores and collection of memories. All the application-level data are available across different sessions, and they are shared across conversational threads. Then we have state, which is really important. The state actually is a history of previous conversations we had with the system, with the smart agents. And the state consists of a bunch of messages, human messages, AI messages, that are messages returned by the large language model, tool messages, which contains the results of a tool invocation. Then we have few short examples with hypothetical questions and hypothetical and preferred answers. Then more instructions, and finally we have structure output, where we ask the large language model to reply in a specific format. It could be bullet points, it could be a table, a class, or whatever, so it's easier for us to actually use it to actually consume the answer. And yeah, finally, everything is organized in a prompt template that pulls everything together, the system message, the examples, the user query, and everything. And basically, these are the building components of smart agents. Okay, now we need to get this building, these components and use them inside nodes, and then get those nodes and connect those nodes with edges, and then create graphs. And in the LangGraph framework, the graphs are finally the agents, so we can really start building smart agents. As I said before, the graphs have nodes. The nodes are connected by edges. Inside each node, we can plug in any of the components provided by LangChain, but it's totally optional. So we can use large language model, vector stores, retrievers, MCP servers, etc. And at the center of everything is the state. The state gets updated at every node, and eventually the state forms the final answer. So the state is the fundamental part. Here, the state is represented by a data class. It can be used as a data class, a type dictionary, as in this example. We can have a pydantic class if we need some kind of validation. And the state actually, it holds, the object holds the search state across all the nodes. And for this example, we use graph state, which is a type dictionary, stores all the messages that are exchanged between the user and the large language model. The state can also be stored between different conversations using what we call checkpointers, and this allows the agent to retain memory. Okay, now the nodes of the graph are just Python functions. They take the current state and return an updated version of it. In this example, this is a dummy node. We can see that the hello node gets the state, returns the state, actually returns one message, and this message is appended to the state and it's available to the next node. Inside a node, we can also invoke a large language model. For this example, the chat node, we use Chat OpenAI, which is part of the LangChain OpenAI package. We call this method. We use temperature 0 so that the model will be more deterministic. And then the response is stored, is appended back to the state. The state is returned, and then this is available to the next node in the graph. Inside the node, we can also execute some tools. Okay, the tools are actually Python functions with just a tool decorator. They take any input and they can return any output. They can also store variables in the state. And since the large language model itself cannot run tools, it only returns the instructions for which tools to execute. LangGraph provides a pre-built node, which is called tool node. It gets as an argument a list of tools, and it handles the execution of the tools. We can also inside a node interrupt the agent's execution to request user input. In this example and in human approval node, we get the response from a large language model, and then we ask the user to either approve or reject it. The result is appended to the state, and then this result becomes available to the next node. This is what we call, by the way, human in the loop. LangGraph also provides two special nodes that indicate the beginning and the end of the graph, which is the start and the end node. Okay, the nodes are interconnected with edges. So we have some edges that are what we call normal edges, going directly from one node to the other, to the next one. We have conditional edges that use a function to decide which node to go next. So the function takes the state as an input and returns a literal with a list of the available nodes, of all the possible available nodes. And edges can also route execution to a dynamic set of nodes that are not predefined, similar to the map-reduce paradigm. Okay, now that we have covered the basic building blocks of the graph, which are the state, the nodes, and the edges, let's look at some examples and some patterns that we can follow when building our own. Okay, let's start with a simple graph that contains only one node, apart from the start and the end. The node is called chat model. The graph takes the user input, invokes a chat model. For this example, we use the GPT-4o Mini. So you see that we import the class from the LangChain OpenAI package. We need to install it before I run the example. And then invokes the chat model, gets the output, and prints all the messages in the state. Both the user input and the model answers, everything is printed to the console. We also use invoke, or we can also use stream. Okay, this is a more complex graph that uses a chat model as a router and directs traffic between two nodes, the backend or the frontend node. Either if the issue is related to the backend or the frontend. The routing is based on the content of the prompt, determining whether it relates to a backend or related issue. So for this case, the chat model should return a structure output. Here we can see, which is the root decision, which is a literal, and it's frontend or backend. You can see that the conditional edges are represented in the graph with dashed lines. Yeah, we have another pattern. So in this one, the chat model decides whether to handle the question directly or to call a tool. In the latter case, it provides all the necessary information, like the tool name and the arguments, and pass the floor to the tool node. The tool node then executes the appropriate tool, because as I said before, it takes as an argument a list of tools, and then the result is sent back to the user. And another common pattern is what we call the reflection graph. In this one, we have two nodes. For this example, we have the generate model. This is a node that calls, for example, a large language model to produce a report. Then the report is sent to the review model. The review model can invoke another large language model or the same with a generated report and ask for a review. If the review is not okay, the comments with the text are sent back to the generate model, and the generate model will just invoke again the large language model for a better version of the report. But if the review model is satisfied, then the final report is sent back to the user. And this is what we call the reflection graph. So, as you can understand, we can build more complex graph with parallel execution with many tools. For example, search the web, search Wikipedia, with RAGs, with MSP servers, MCP, okay? Even more complex graphs with more nodes. We can have graphs with interrupts for human in the loop, for human approval, or maybe human to edit something. Or for example, if we are about to call a tool that will take some action, we perform a post request, and maybe we need the user to approve the action to be taken. And finally, we can even nest graphs inside other graphs, creating multi-layered architecture, modular workflows. So for example, we can have an initial task, which is the user prompt. This will be fed to a node, and the node will ask from a large language model to split it in multiple subtasks. And for each subtask, another graph, a subgraph, can be called, which implements a sub-agent. And yeah, you get the basic idea. So that is how we build agents and multi-agents. And now let's focus on a very important agent, React. No, not this React, okay. This React, okay. It is stands for reasoning and acting. It's kind of the hello world example for smart agents. It looks like a lot like the graph that we saw earlier, but here the tool node can route the traffic back to the chat model. So the chat model will get the output from the tool and can decide to call another tool or the same tool, or just provide the output directly to the user. As I said before, this is a so common agent, so it is implemented in LangGraph. LangGraph provides a specific function, create React agent, so we don't need to create all the graphs, the nodes and the edges we saw earlier. We just need to fill some variables, some variables with a large language model, a list of tools, and checkpointers to keep state. And actually, there is a module in the LangGraph package with ready-to-use agents like this one. Okay, now we built the agent. It's time to deploy it. We have 3 options. The first option is to use a popular Python web framework like Flask, FastAPI, or Django. In fact, there was an interesting talk yesterday, I think, or a workshop on how to deploy smart agent or a machine learning, if I'm not mistaken, with FastAPI. So you can see this. And the catch here is that we need to manually take care of things like the state persistence and the storage ourselves. Next, we can use the LangGraph CLI tool and the LangGraph server. This will create and launch a LangGraph server. So this option builds the application so it can be used with Docker Compose. It builds certain Docker containers, the applications with all the available endpoints to hit the application and the Redis and Postgres. And it provides out-of-the-box functionality for streaming, for long-term storage, for checkpoints, and for human in the loop, with some limitations, some restrictions. And finally, we can take the artifacts from the previous step, and we can deploy them to the LangGraph platform. This is a commercial solution, but it provides a lot of benefits like monitoring, tracing, and it's very easy. Okay, and now let's move to a demo. Okay, here you can see the Docker desktop. So I use Docker desktop in order to start a Kubernetes, locally a Kubernetes cluster. Okay, as we can see, it is running. Then I can, okay. Okay, I can launch the dev server, that it is used basically for experimenting before going to production. It's very convenient, as you will see. Okay. Here we are. Okay, here we see the React agent, the diagram with the React agent. Okay, and many features. I can also use the chat interface, but I prefer the graph one. Okay, let's see the chat interface as well. Okay. Okay, now I can go here and I can say, for example, hello, my name is Michael. Okay, and I can submit it. So here we will see a new thread. And we can see that this time, the large language model, I think I use GPT-4o mini. Okay, so we can see that it took like 9 seconds. We can also see the trace. We will see this later. And the agent choose not to call the tool node, but respond directly to us. Now, in another invocation, I can... Sorry. I can say, what is my name? Okay, and you will see that the state persists. So in the second turn, the agent didn't call the tool node because it could handle the prompt. So your name is Michael. So we can see that the thread ID, it keeps all the state. And finally, I can say, okay, how many pods are running in the default name space. Yeah. And let's see. Okay, now the agent decides to call the tool node. The tool node responds back to the agent. The agent takes the output from the tool node and then return the final, the final answer to the user. So you can see here that the agent, okay, decided that should invoke the tool, the getPods tool. This one responds with 1 because I'm currently running 1 pod. And finally, the answer provided by the agent that there's 1 pod running in the default namespace if you need more information about it, etc. And last but not least, we can see here the state. Give me a sec. Okay, you can see all the state that it is preserved. And finally, we can see the trace and debug what's going on. So we can see latencies. Explore many things. For example, GPT-4o mini. We can see that all these tools are, the GPT model is aware of my tools, and it should continue. Okay, maybe we can see the output from the tool, which is 1. You see that this is the call from the model to the tool node. The tool node gets the name of the tool and the arguments. The response is 1, and then this is fed up. It's fed up back to the model, to the agent, and the agent responds to us with just 1. Okay. That's it. Thank you. Thank you very much.
Thank you so much, Michael. We have a couple of minutes for questions. I see one hand here.
Thanks for this presentation. I'm trying to compare with something I heard earlier. It's called Pydantic AI. So one question is this: how these two are comparing with each other? As I understood, they do the same. They serve the same purpose. Second thing is that if your tools were actually using MCP here, which wasn't clear to me. These two things, if you can elaborate a bit. Thank you.
Yeah, so regarding the first question, okay, I don't have an answer. It's like comparing Flask with Fast API with Django. You know, I can share my personal story. When I started, there was Pydantic AI and LangGraph, but for me, LangGraph is like a LangChain, the whole LangChain ecosystem with all packages is like having batteries included, which is the motto for Django. So I can have, you know, with not many code, I can have all this dashboard and examine everything and the latencies and see what's going under the hood. And regarding the second question was a MCP, yeah, I can use MCP. I mean, the MCP actually provides a toolkit, which is a bunch of tools of the same category. So this can be integrated into a node, and this will be taken into consideration from the large language model. So, yeah, There was a presentation from Thanasis Politis yesterday, how to build MCP servers, and this was integrated into the Claude, if I'm not mistaken. So the same process almost is to integrate it with LangGraph and use it in your own smart agent.
Perfect. That's all the time we have today. Thank you so much. You can grab Michael at the break.
Thank you.
I think we're ready to begin. Next up, we have Konstantinos Papadopoulos, who's going to give us a talk about turbocharging your Python test suite today. Warm welcome to Konstantinos.
Welcome, everyone, and thank you for joining today. So I'm going to leave the link to the slides. You can scan them if you want to follow along from your device or for future reference or whatever. My name is Konstantinos Papadopoulos. I'm an electrical and computer engineer from, you guessed it, from Greece. And for the past 5 years, I've been working as a software engineer and doing some stuff with open source, one of them being the maintainer of our stuff, an OpenSSF project, and some other smaller personal projects. So a few years back, one of my friends sent me this quite popular meme, the number one legitimate reason for programmers to slack off, compiling. To which I replied something like, yeah, I guess then we Python devs don't slack off. I lied. Turns out we too can slack off, and that's testing. So jokes aside, having worked with a few code bases with hundreds or thousands of tests, there are cases where the time for the test to complete is can become counterproductive. So let's see a bit more why that can be. So a typical developer workflow looks something like this. You write some tests, and then that fail, and then you try to write some code to make your test pass, or the other way around, depending on the school of testing you're from. So after you've got your code running, you want to check that it plays well along the rest of your code. So you run some integration tests. You find some bugs, you fix them, you run your internal tests again, you run your integration tests, and you repeat those cycles until you have everything running. And when you're finally ready, you can give your code for the valuable peer review, get 50 comments back, and repeat the cycle again. So you can understand that the more time the tests take to complete, the easier it is to get out of your zone, and this could actually mean fewer code feedback cycles. Another important thing is the mean time to repair. So a typical continuous integration and continuous deployment pipeline looks something like this. So after you build and before you push to stage production your code, you usually want to test it. So when that critical bug comes out and you want your fix as soon as possible, this could mean more time to get the correct code out there. Of course, you could bypass the tests, but eventually, at some point, you would be adding another bug. So highly not advised to do so. And of course, with most CI/CD pipelines running on the cloud nowadays, longer test times could mean a higher bill at the end of the day. So back to today. What I want to show you today is some simple and quick methods, meaning not very intrusive methods, not rewriting your whole test suite necessarily, to tackle the problem with your test taking too long. We're going to be speaking about a step after measuring. So of course, most of us work in a business environment where we cannot just go and over-optimize everything, but this is some methods you can quickly apply when you've noticed that there is a problem for the reasons mentioned before or for some other reason. And I'm mainly going to be using PyTest in my examples, but the general principles can be applied in any framework or library. By the way, all the examples have a link at the end, so you can find them. So let's talk about fixtures. In general, fixtures in software testing are entities that can be used to mock or easily reuse data in our tests. In PyTest, having a fixture is as simple as decorating your function with the PyTest fixture decorator. So in this simple example, very simplistic one, that we test the add function, instead of passing the numbers we want to test every time, we just pass the fixture as an argument to our functions. That's great. Now let's see a more realistic scenario. As I mentioned, we use fixtures in places where we do repetitive work, at least one of those use cases. So let's say we want to test reading and writing to a table on our database. We always want to connect first to the database. So what we can do with PyTest is define a fixture again, as I mentioned, that first sets up a mock session. I've added a delay of 2 seconds just to simulate that setting up. And also on the right, you can see I have a typical life cycle of a test. So that means that before the test runs, this fixture will load, set up the database when it's being passed as an argument. And after that, it will also tear down the database, which can also take some time. So if we run this dummy test, it will take about 4 seconds, because by default, fixtures in PyTest are created every time we use the function. So 2 times the simulated delay and 2 tests is the 4 seconds you see. So what is very important is to start thinking the scope of our fixtures. So if we have a test like this one, where writing to the database doesn't affect the tests, we can simply define a different scope for our fixture, basically caching our fixture in the context of, in this case, the module. So when I run the test now, it will only take 2 seconds, since the scope is not destroyed at the end of each call of the functions. There are also other scopes that you can use in PyTest, like the function scope, or if you're using classes, you can define a class, or even the whole session, depending on your tests. Let's see another method, actually one that might be one of the quickest wins when you have a very slow test suite, and that's distributed CPU testing. To set you up a bit with our example, we just create a dummy delay of 2 seconds for our test, a test that just 11 tests actually that just pass, and 1 extra test just to make it a 12 even test. So we have 12 tests with a 2 seconds delay. If we went and ran that with PyTest, just simply PyTest and running those tests, it will take about 24 seconds, right? We have 12 tests and 2 seconds delay. So what PyTest does is goes over each test and runs them sequentially. If you also see the processes related to PyTest in your machine, you will only notice one PyTest process. So having, especially nowadays, modern machines with multiple cores or that support hyperthreading, we can take advantage of that and have a setup like this one, where we have a controller and we distribute the tests into different workers inside our own, inside the same machine. One way to do this is with the PyTest Extist plugin. So first of all, PyTest plugins are basically packages that extend functionalities of PyTest. Some of them are created by PyTest. You can create your own. There's quite a big community and variety of plugins you can use. So going back to our example, using PyTest Extist, you can call it as seen on the screen. You can say PyTest minus n auto, which means use the same number of workers as the physical cores on your machine. So my machine has 6 cores, and it will spawn 6 workers, and what took before about 24 seconds now takes about 5 seconds. Just to verify, yeah, I have 1 core, and you can see now that on the top there are 6 processes created from PyTest, and a 7th one, which is actually the controller. But you can also take advantage of this on your CI. I use GitHub Actions here, but yeah, you can typically do it in any CI. So you can see that your one standard runner has 1 core here, but 2 threads. So instead of using the number of physical cores, you can actually use the number of logical cores and use PyTest Extist again. So yeah, in this example, again, 25 seconds if we just run with a single CPU, and if we just use the extra thread here, we cut it down. We use 2 workers and cut it down in half. And another nice little neat trick I like to do is, especially when working on monorepos and you have a set of tests that you always want to run by your team, or you're working on a new feature, I use Git hooks. So Git hooks are scripts that you can run before specific stages of Git, like before pushing or before committing. And specifically here, I use the pre-commit tool. And you can specify that you want to run a subset of your test with xtist, so it will run much faster. Here's a small example. So before committing, maybe it's even more practical, before pushing your code and loading those failures to the CI, you can just test them locally first. To conclude with this method, this is generally great with unit tests, which are usually isolated tests. You're not changing the state of a database or another service outside. It's very good for running on your device, as I showed, but you can also take advantage of it on CI. And some things you might want to consider is what we talked about, the fixtures before and the scope. They will not run by default. You might be losing some of those advantages. And you also need to think of the working distribution. Before, we just showed a simple equally distributed scenario, and that uses round robin. But there are a lot of other options you can use. Some other caveats that are related to specifically to this plugin that I showed is that you cannot use the PDB debugger, and standard output and standard error from the workers is not visible while you're running the test. And last but not least, the order and amount of tests should be consistent throughout your tests. So if the last condition is not met, you might need to change a few things before you apply using PyTest xtist. So we talked about using maybe cores or threads in your own machine, but you can also do some horizontal scaling. So similarly to before, you can split your tests into different groups and use a distributor to fan those tests out into different machines. This is great for integration tests and end-to-end tests, which might have a bigger load on your machine and might be changing the state of different services, again, like a database. It's very good for running on your CI because you can spawn multiple machines. And you can also get quicker feedback. So one of the set of tests fails, you can already start working on it. And so we're going to see how to use that using the PyTest plugin, PyTest Split plugin, which is another plugin of PyTest. We can use markers, and basically you can use any other strategy you want to decide how to split your tests in different machines. So using the plugin I mentioned, it's as simple as defining the number of splits, so the number of different machines you want to use, and running them by group. There are two main algorithms you can use to do the splitting. One keeps the absolute order of the tests and uses a duration-based chunk. So basically, the algorithm just finds the optimal spot in which to put the boundaries and split the tests. And something that's usually more performant is using the least durations algorithm, where the relative order is maintained. So test 4 is after test 1, test 5 is after test 2, and so on. But basically, the algorithm in this case goes by each test one by one and puts it in the chunk in the worker with the least amount of testing duration. So yeah, you might ask how we know the duration of each of the tests. The plugin assumes an average testing execution, but you can also store them periodically using the PyTest store durations parameter. So you can have some statistics and you can distribute your tests a bit better. Again, an example on CI on how to use that. You can use the matrix strategy, set your number of PyTest groups, and just as one of the steps, use that parameter to run with PyTest splits your specific test group. To show you the truth, yeah, using three workers here instead of 24 seconds that we had in the beginning that we ran the test sequentially, now we have about 9 seconds per worker, of course. But again, we have the advantages of quicker feedback and our tests passing faster. So as I mentioned, we can also use PyTest markers. This is basically just a decorator on top of your tests. You can define them however you want. You can say that I have some fast unit tests or some fast end-to-end tests or some slow end-to-end tests. This is just to split your tests into different and not different queues, let's say, and not have them waiting for some slow tests. Again, it helps with getting quicker feedback, and you can just run it as displayed on the screen with the marker. Now, we talked a lot about the test phase, but just one step before is usually the setup, especially when running on your CI. Every time your setup is a clean slate. So caching some of those dependencies is great, especially if you have large builds and builds that are very frequent. And you also, if you want to work in an environment that you want to minimize network calls. Let's see another example how you can do that with GitHub Actions. In this case, the setup Python action, a very popular action, has by default a pip cache option. Basically, it checks every time if the requirements.txt file or the PyProject TOML file has changed. And if it does not, it uses the cache. Otherwise, it's in the hash and it creates a new cache. There's similar actions for poetry and other tools. I think also for pipenv. So this is just an example with pip. So in the first scenario here, the cache is not found when we run the setup. But if we run it again, and we don't change the requirements or the PyProject.toml file, you see that the cache has been restored. The difference here is pretty small. Like the first one was 7 seconds, the second one is 5. But the bigger your builds are, you're going to see a bigger difference, of course. So in the interest of time, I did not have a full-blown example here, but you can also find it in the link. But a lot of us use containerized applications. So another great thing you can do is use Docker's layer caching and just cast the layers at the right spot. Because, of course, we don't only use Python dependencies, but you might use Node, or you're setting up and downloading your database is something that also takes quite a load on your test suite. So here you see it takes about 2.3 minutes to build for the first time. And using the cache, it takes half the time in this very simple example. Now, one last thing. I promised I wasn't going to show very intrusive methods, but this is something really interesting I first read about in a great book called Architecture Patterns with Python, and is differentiating what to test versus how to test it. I'm going to set you up again with a small example. Let's say we have a very simple client application, which we send some messages. A text message that's simply a string, and a picture message with a string and a URL. So we want to send some messages, and let's say if it's a Monday, we send a picture message with some text. If it's a Friday, we send another picture message with relevant text. And if it's any other boring day, we just send a text message. And I added, again, a simple delay of 1 second to simulate some network delay. So this is what we want to test. This is our code. We want to test that we send the messages correctly. One way to do it, without introducing any abstractions yet, I give away what the solution might be, but is to go for every day, and test that for Monday, we send the message correctly, maybe have the appropriate response. The same thing for Friday and for testing for a random day. So we're making 3 different network calls to test our send message function. This, of course, is going to take 3 seconds because we added this fake delay. What we can do now is shift our thinking into how we want to test. So what we really want to know is that we send the right type of message. On the left, you see the code that I showed before, and on the right is using abstractions. So instead of using send message directly, we can delegate the logic to another function, the create message one. And we say that if it's a Monday, create and return a picture type of message. If it's a Friday, the relevant one. And of course, ending with a text message. So now, send message can use this to create the right message and then communicate with the third-party service that actually does the networking call and actually sends the message. With this abstraction here on the right, we can now do a bit of a different type of testing. We can shift into a unit test. So we can test that the Monday message is correct by just using the day and expecting the type of message that we want, the picture message class. And if we want to be in sake of completeness, you might also want to have just a few integration tests to see that your client actually works. So this will take much less time since we're shifting to a unit test and we're not actually communicating to any third-party service. Some other common gotchas is, of course, also in your production code, but in tests as well, is use timeouts in your requests because they might be hanging and your test might be taking more time to complete and they're just repeating requests. Retry with caution. And on a similar note, on production, you might have a specific retry logic that you might not want necessarily in tests if you want them to fake a bit more quickly, even though that might be a bit of flakiness. So you can use environment variables to see where you're running and adapt your logic accordingly. Again, something similar to retry is the sleep calls that in testing could take some time just being idle. For some things that in production might make sense, it might not make sense in testing. And nice little tip is also using the max fail parameter, so you can get, again, quicker results. So if you have 25 tests failing, you don't need to wait for the 26 to start working on them. But I've kept the best method for last, and that is you cannot have a slow test suite if you don't have any tests. Just kidding. Thank you.
Thank you, Konstantine. Any questions for Konstantinos? Perfect. Again, a round of applause, and you can grab him later. This was the last session that we had in this building. Now we follow with the last keynote of PyCon Greece 2025 at Miltiadis Evert Auditorium.